Hello everyone, once again welcome to the session of Brain Lab Techies. In this video, we will be learning complete data analysis. In this video, we will be covering NumPy, Pandas, all the visualization libraries that we are having for the data analysis. All those things we will be covering. So this video will be very long, and this video will be very important for the one who is willing to change their tech stack, or who is willing to come into the data analytics field, or those who are having interviews. For them this video will be very important and very good. I am covering the entire EDA, entire data analysis, and that through within with the help of live examples. We will be taking the data set, and with those data set we will be solving some questions, and those questions we will be learning the methods of Pandas and NumPy, and that will be very important for the one who are learning for the very first time. So without wasting much time, let us go through the session, right? Covering with the overview of NumPy and Pandas, and this video will be very helpful for the one those who are willing for sitting in the job interviews, or those who are learning NumPy and Pandas for the very first time. Okay, so if you have not watched my previous videos, first go and cover those videos and then come to this video. I will be attaching the link for the previous videos in the description box. Just go through it and then come to this video. Fine. First of all, I will be covering through NumPy. First of all, I will be covering through NumPy. Fine. So what is NumPy? NumPy means numerical Python. Numerical Python. Fine. Now, why do we use this NumPy? We will be using this NumPy to do only one thing, that is forceful introduction of array in Python. Forceful introduction of array in Python. Okay, forceful introduction of array concept in Python. Now, what is meant by array? Those who are learning Python, those who are from the Python background, for them this array concept will be very difficult, and it will be very new actually. So let us go through it. What is array at first? So array is basically a way of structuring the data. It is a way of structure the data. Structure the data. Now we have many data types in Python, like list, tuple, set, dictionary, string. Many multi-value data types are present in Python. But why do we need this array? Array is also kind of a multi-value data type. But why do we need this? First of all, how this array looks like. What is the structure of the array? Suppose I am taking one array like this: 10, 20, 30 and 40. Inside this array we are having 4 data value. Now if you look carefully, that this array looks like a list. This array looks like a list because it is also enclosed by square braces, and list is also enclosed by the square braces, right? Now what is the difference between the list and array? What is the difference between the list and array? That we have to understand. Why we will be going for array, why we will be not going for the list? That is the main point. First of all, let us start with the array. Otherwise you cannot get through the list. What is the difference in the memory allocation or the memory structure? What is the internal difference? If we look carefully for array, 10, 20, 30, 40, I am taking 4 data values, and all the 4 data values are of integer data type. All the 4 data what we are taking inside array, all are in the form of integer. Now inside memory, how our memory looks like? Our memory looks like a long chain of memory blocks. A long chain of memory block. Suppose this is your memory space where each and every individual data elements are getting stored. Each and every individual data elements are getting stored. Fine. Now if we look for array, array stores this data element in a contiguous order, and this is the most important concept about array. Array stores each of the data elements in a contiguous order. Contiguous or continuous order. Continuous order. Okay. So what is meant by contiguous or continuous order? Array is storing each of the elements in a simultaneous way in each of the memory block. Like 10 will be stored over here, 20 will get stored over here, 30 will get stored over here, 40 will get stored over here in the continuous way, in a simultaneous way. Fine. Now suppose I want to access this 30. How can I access this 30? With the help of indexing, because array is also a kind of multi-value data type, right? So we can access this 30 with the help of indexing. Suppose I am storing this array in one variable named as L or A. Better give it as A. So I can access like this 0, 1, 2, 3, and if I give A of 2, it will be giving you what? It will be giving you 30. Now actually it is not happening internally. Internally it is represented in a kind of different way. 0, 1, 2, 3. Okay, and what I have said that each of the elements are of integer data type. And what is the size of integer? The size of integer is what? 4 bytes. 4 bytes. Okay, now each of the memory block, definitely it will be having one memory address. Suppose it is starting with 100, and as because one block is taking 4 byte, so the next block obviously it will be 104, very next byte will be 108, very next byte will be 112, like this it will go on. Now suppose I want to access this 30, right? How can I access it? With the help of indexing. Now actually inside the memory it is not happened like this. Inside memory what happens? Suppose I am giving a of 2, it is taking as like this. Memory, not memory, base address plus index number, into size of int, size of int. What is the base address? Base address means from where we are storing, from where we have started our array. Like in this case, from where we are starting our array? From 10. And what is the address of 10? That is 100. Fine. What will be the index number? The index number we have taken as 2, as because we want to access 30. And what is the size of int? The size of the int is 4 bytes. So 100 plus 2 into 4 is 8. That is 108. And in the 108 position, which value is there? That is 30. That is 30. And how can I access all the elements? With the help of the index number, but with a different method. So this is the method how we are accessing each elements inside the array. Fine. Now coming for list. List doesn't work like this. What happens inside list? Suppose I am taking one list like this: 10, 20, 30, 40. Fine. And it will also get stored in the memory location, in the long chain of memory block. Suppose it is the long chain of memory block. Now in list what happens? It is not storing the elements in a continuous order or in a simultaneous order. It is storing it in a random order. Suppose 10 will be stored over here, 20 will get stored over here, 30 may be stored over here, 40 may be stored over here. So obviously it is the integer data type, and each memory, each block will be of 4 byte. So I'm taking the base address as 100, then 108, 112, 116, 120, 124, 128, and 132. Like this the memory will get stored. Now suppose I want to access this 30. I want to access the 30. What I will be writing? I will be using the index number, like L of what? 0, 0, 1, 2, 3. I want to access this 30. So obviously I will be writing L of 2. Now can I use this same method? Can I use this same method to access this 30? Let's try it. What is the formula? Formula was base address. What is the base address we are having? That is 100. The base address means from where we are starting our multi-value data type. Fine. So 100 plus, what is the size of integer? Size of the integer is 4 byte. And what is the index number? Index number is 2. So 108 it is giving. So in the 108 position, is the 30 is there? There is no value is there. So we cannot access any element of the list with this method, as because the elements are not stored in the contiguous order. So how can I access the elements inside the list? See, in list what happens? List is using another type of data structuring way, that is linked list. List is using linked list. Those who know, For them it is fine, but those who don't know, for them also no need to worry about it. I am explaining it in gist. Okay, suppose I want to access this 30, right? So in list, how the data elements are stored, see it. First element is 10, right? First element is 10. Now what is the next element? 10, 20, 30, 40, right? 10, 20, 30 and 40. Now if we just compare to it, compare to this memory allocation, 10 is stored in 100 place, 20 is stored in the 116 place, 30 is stored in 112th place, and 40 is stored in 132th place. Fine. Now, what 10 will be storing, when I will be storing the 10 in memory, it will be storing the address of 20 in it. It will be storing the address of 20 in it. What is the address of 20? That is 116. So it will be storing 116 over here. Is there any previous value before 10? There is no previous value before 10. So before 10, it will be storing null. And this entire thing is one node. So inside one node, it will be storing the data value, the address of the previous data, and address of the upcoming data. It will be storing the address of the previous data as well as the address of the upcoming data, so that it can access the upcoming data. Now what is the next data? Next data is 20. So 20 is stored. So what 20 will be storing? 20 will be storing the address of 10. What is the address of 10? Address of 10 is 100. And what is the upcoming value for 20? That is 30. What is the address of 30? That is 112. It will be storing the address of 112. Now like this, every elements are getting stored. Each and every elements are getting stored. Now in this way, we will be accessing each and every elements inside this list. Now just think one thing, that inside array we are storing every elements in a contiguous order, and that is why we can access elements very easily by using this formula, by using this method. But in list we cannot use like this. We cannot use that method. Rather than we will be using the linked list. Now in array it will be very fast, obviously, and the second thing is it is consuming less memory. Just think about list. For storing one element, it is taking almost 2.5x of the memory. Now in this era, when we are generating almost 1 to 2 GB of data in each and every minute, right, and we are doing the big data handling, now in this era, so much of memory is getting generated with list. We are increasing the memory with list, and that is why we are introducing array. With array, what are the things we are doing? With array, we are decreasing the memory space. We are decreasing the space complexity. Space complexity. And if the space it is taking, if it is taking less space, obviously the time complexity will be less. Obviously, the time complexity will also be less. If the time complexity will be less, then what will happen? Data processing will be faster. Data processing will be faster. Just see for the list, it is taking almost 2.5x more memory to store 4 values, right? What, how much data it is taking for array? 4 into 4, that is only 16 bytes of memory it is taking for array. But just check for list, it is storing one value over here, one value over here, one value over here, just for storing one data value. So how much more it is taking, right? And that is why we will be going for this NumPy concept. Now I guess it will be clear for you that why we will be going for NumPy. NumPy is just a framework in Python by which we will be forcefully creating array data structure in, or we will be forcefully introducing array data structure in Python. Fine. Okay, so now let us move on to Colab, and let's watch this NumPy in a more practical way. As because if I write NumPy in OneNote, that will be not very realistic, not very practical way to understand NumPy. Okay, so how a list looks like? See, the list is looking like this: 10, 20, 30, 40. If I take this list, what will happen? This list will getting executed, and if I run it, it will be giving you just, it will be just returning you this list. Now if I go for the NumPy array, if I go for the NumPy array, first thing what you have to do is you have to import NumPy, as because it is not coming in your default Python version. You have to import it. You have to import it. For importing, what you will be doing? Import NumPy as NP. So what is NP? NP is just the alias you are giving for NumPy. It is just the nickname you are giving to NumPy. Fine. By which you will be using NumPy this, because you will be using this NumPy word multiple time in your entire curriculum. Whatever you will be doing, whether you will be going for data analysis or machine learning, whatever you will be doing, you will be using this NumPy word multiple time. So as because you don't want to use this NumPy word, this 5-lettered word multiple time, what you will be giving? You will be giving one nickname to it. I hope you know it. So now how to create a NumPy array? For creating a NumPy array, you will be using like this: np.array, np.array, and under it you will be just giving one parenthesis and one square braces, and inside it you will be just putting all your data values. I am taking 1, 2, 3, 4, 5. Fine. Now see, this array is executed and your array is forcefully created in Python under square braces. Now there is one difference, that is inside list it is directly coming in square braces, right? But in array it is not coming directly in square braces, rather than it is mentioned as array, which is enclosed by these parentheses, and then it is enclosed by the square braces. Now this is the difference. This is the only structural difference between the list and array. And if I go for the like architectural difference, I have already explained you over OneNote, right? Now I want to store this array in one variable. How can I store it? Simple, just how we use list, how we store list. ARR, I am taking one variable, ARR is equals to np dot array, and inside it you will be just writing the same thing: 10, 20, 30, 40, 50. So inside ARR variable you have stored this array. Fine. Now you can execute it. So NumPy is what? Why we will be going for NumPy? NumPy is faster. It is taking less memory. It is like with Python we can with the NumPy we can do more mathematical operations, and most importantly it is the backbone for machine learning. Why? Why? Because in machine learning everything will be calculated in the form of matrix, in the form of vectors and matrix, right? And for matrix calculation, matrix multiplication or addition, or whatever the operations we will be doing, that will be done in the form of matrix only. And in computer science all the matrix operations are possible with the help of array, and that is why one of the reason we will be using, or we will be introducing array in Python. Fine. I hope it is clear. Now let us move on for 1D array, that is one dimensional array, or in mathematics you have already learned about one dimensional matrix. So this is the way how you will be creating the one dimensional matrix or one dimensional array. How you can create? Just like this. This is the way how you can create this 1D array. If you just run ARR, it is giving the output in one row, in only one row, and it is only the one dimensional array. Now suppose you want to create the 2D array. What you will be doing? B is equals to ARR, B is equals to ARR, sorry, np dot array, np dot array, and inside it if you just put double square braces, remember this thing, 1 comma 2, and give one comma over here, and if you just give 3 comma 4, 3 comma 4, if you just run it, it is creating the two dimensional array. Now if you just run B, what it will be giving? See, it is giving in two rows, it is giving in two rows and two column, and that is why it is two dimensional array. Fine. And we will be covering those things which will be really essential for doing your data analytical stuffs and the machine learning. We will be only covering or going through all those methods. And there is one more important thing about NumPy, that is we will be going through many methods of NumPy, but in NumPy method there is one specialty, that we will not use this open close parenthesis. Like for taking one method, whether it is an inbuilt method or a user defined method, whatever it is, we normally how do we create method? by using this open close parenthesis, but in NumPy methods we will not use any open close parenthesis. Fine. Now suppose I want to create a matrix for zeros. I want to create a matrix for 0. What I will be writing, see, np dot zeros. I will be taking one method np dot zeros. Okay, and suppose inside it I want to create one matrix. I want to create one array. How I will be writing, see, 3 comma 4. If I just write what it is giving, it is giving me a matrix with 3 rows and 4 columns. It is giving me a matrix of 0 with 3 rows and 4 columns, and this is how we will be creating a 0 matrix. Fine. Suppose we want to create a matrix of only 1. How I will be creating, see, np dot ones, and these things will be really essential. Np dot zeros, np dot methods, np dot ones, these methods will be really essential for your machine learning journey. Okay, so remember this thing very carefully, learn these things very carefully. Okay, 2 comma 3. Now see, it will be creating one matrix with 2 rows and 3 columns, and every data values are containing 1. Now suppose I want to create one identity matrix. I want to create one identity matrix. I will be using one method np.i. np.i. Okay, so I'm just passing 3 over here. See, it is giving one identity matrix of 3 rows and 3 columns. 3 rows and 3 columns. So it is creating one identity matrix. Now suppose I am using one another method, arrange. I want to create, what I want to create, I want to generate values in between 1 to 10. I want to generate values in between 1 to 10. What I will be doing, np.arange, np.arange, and I will be giving a comma 1 comma 11. So it will be generating all the values between 1 to 10. So 11 is excluded. It is giving me, it will be generating the values between 1 to 10. 11 will be excluded. Now let's run it. See, it is generating the values between 1 to 10. Fine. Now suppose how can I use arrange method in multiple way? How can I use arrange method in multiple way? Suppose I want to generate all the even numbers in between 2 to 20. Let's assume in between 2 to 20 I want to generate all the even numbers. What I will be writing, np dot arrange, and I will be passing from where I want to start our generating numbers, 2. Okay, from 2 I want to generate 2 to 20, I am saying. So obviously the last digit will be excluding. What I will be writing, so 21, and I want to print values in alternate ways, 2 then 4 then 6. So I am skipping 1 values in between. So that is why I will be giving the third argument, that is the updation step. So what will be the updation step? Updation step will be 2. That how many steps we are moving ahead. So how many steps we are skipping? We are stepping 2 steps ahead, and that is why we are giving the updation state as 2. See, it is generating all the values in between 2 to 20, which are even numbers. Fine. Now suppose I want to create linearly spaced numbers. I want to create linearly spaced numbers. What is linearly spaced numbers? Suppose in between 0 to 100, you want to generate 5 numbers which will be in equal interval. In between 0 to 100, you want to generate the numbers which will be in equal interval. What you will be doing? You will be using one method, that is linspace. np dot linspace. np dot linspace. And here you want to generate 5 numbers in between 0 to 100. 0 comma 100. And you want to generate 5 numbers, right? So you will be writing 5. See, it is generating 5 numbers, 0, 25, 50, 75 and 100, and every numbers are at equal interval. Suppose in place of 5 you are giving something different like 7, so it will be obviously giving some decimal values. See, it is giving the values at every fixed intervals, at a regular interval, right? Now there is one important method, that is set. It is very important for the data analysis. In the perspective of data analysis, this shape method is very important. Suppose you are having one two-dimensional array or two-dimensional matrix, or you are having one data set which is having 2 rows. Let's assume this matrix as data set. So ARR, let's create one data set, or let's create one matrix. ARR is equals to np dot array, and inside it you will be passing 10, 20, 30. Fine. As because it is a 2D array, so again one square braces, 40, 50 and 60. Fine. Now let's run it. Let's print error. It is giving me a 2D array. Now I want the shape of this matrix. ARR dot shape, and it will be giving me 2 comma 3, as because it is having 2 rows and 3 columns. Fine. It is giving me 2 rows and 3 columns. Now suppose I want to check the dimension of this matrix. I am saying you that it is a 2D matrix. How can I prove it? Using one method, that is ndim. ARR dot ndim. ARR dot ndim. It will be giving 2. Why? Why? Because it is a 2-dimensional matrix. Now there is another method, that is size. How many data elements or how many data points are present in this entire matrix? In this entire matrix, how many data values are present? ARR dot size. ARR dot size. What it will be giving? It will be giving 6. How many data elements are present? Because 1, 2, 3, 4, 5, 6. 6 data elements are present. Fine. Now suppose you want to check the data type. ARR dot D type. What it will be giving? It will be giving int 64. Why it is giving int 64? Because all the values inside this array are of integer data type. Now suppose you want to access this 50. You want to access this 50. How can you access it? You can access this data element with the help of indexing. With the help of indexing, you can access this 50, right? Or let's be simple at first. Let's be simple. Let's go for 1D array at first. A is equals to np dot array, and inside it I am going through 10, 20, 30 and 40. Fine. Now suppose you want to access this 30. You want to access this 30. What you will be doing? 0, 1, 2. So it will be in the second position. A of 2, like how normally you do indexing, the same way will be also be done for the indexing in array also. Same thing will be done in array also, like how you do the indexing. A of 2, what it is giving? See, 30. It is giving you 30, right? Now suppose I am taking one 2-dimensional array, that is this ARR. You want to access this 50. You want to access this 50. What you have to do? First of all, let's print this array at first once again. See, you want to access this 50. This 50 is in which row? This 50 is in second row. This 50 is in second row. First row will be represented as 0. Second row will be represented as 1. Third row will be 2. Fourth row will be 3. Like this, it will be going on. So first of all, you will be writing the variable name. After that, you have to access the second row. Second row. Then in the second row, you are accessing the first element, 0, 1. You are accessing the first element. What it is giving? It is giving you the error. Why it is giving error? Now why it is giving error? Why it is giving error? Why? Because see it that indexing always starts from 0, and this 50 is in second row. I am saying it is 50 is in second row, but the indexing starts from 0, right? So 0, 1. So it will be 1 instead of 0. It will be 1 instead of 0. So 1 comma 1 1, if you will be writing, then it will be giving 50. See, now it is giving 50. Like the same way how you have done the slicing will be also applied in array, in the NumPy array. Like the same way you have gone for the multi-value data types also. Fine. Okay, so now suppose you want to generate random numbers, 5 random numbers. Okay, you want to generate 5 random numbers. Np dot random, there is one method known as random. Okay, np dot random dot rand, and here you will be passing 5, and if you will be passing 5, it will be generating 5 random numbers, and every time you will be running this thing, it will be generating new numbers. Just check this number 0.99, 0.94. Again I will be running it. See, again different values will be coming. So every time you will be running this random function, it will be generating new values. Now suppose you want to generate random numbers in between 1 to 100 within a certain range. Basically you want to generate random numbers or random integers in between 1 to 100. See, it is not giving the integers, it is giving you the float value. It may give you float value, it may give you integer value, anything it may give. Now suppose you want to generate random integers in between 0 to 100. Okay, np dot random dot rand int, and you want to generate random number between 0 to 100. See, it is giving 19. Why it is giving 19? Only 19 it is giving, as because you have not mentioned that how many random numbers you want to generate. Now suppose you are passing the random, how many random numbers you want to generate. Suppose you want to generate 5 random numbers. See, it is generating 5 random numbers in between 0 to 100, and all the numbers are integers. Okay, all the numbers are integer. Now suppose we are having categorical values. Now suppose we are having categorical values. Fine, like male or female or string type value, you may say. np dot random dot choice. So basically your computer will be choosing in between male or female. Any random thing it may choose. Any random thing it may choose. Okay, np dot random dot choice. You are giving the values as male and female. Suppose female, female, and here you are passing as 10, as because you want 10 choices from computer. See, random choice is it have made random choices. Fine, and all the methods what I have discussed just now, all the methods will be very very important for the entire EDA to machine learning, and this is all about NumPy. This is all about NumPy. If you can successfully learn all the methods, if you can successfully go through all the methods, your entire, like almost 90% NumPy will get completed for your entire lifetime. And this is all about NumPy. And now let us move on to Pandas. Okay, so now we will be going for Pandas. अभी देखते हैं Pandas का क्या सीन है, right? So Pandas है क्या? First of all, what is Pandas? Panda भी और एक लाइब्रेरी है NumPy की तरह, जो कि पाइथन में है, एंड वी विल बी यूजिंग पैंडास मोस्टली फॉर द डेटा एनालिसिस एंड डेटा प्री प्रोसेसिंग. फॉर द डेटा प्री प्रोसेसिंग एंड डेटा एनालिसिस ये पैंडा बहुत इंपॉर्टेंट काम करेगा, बहुत इंपॉर्टेंट काम करेगा पैंडास. नाउ we will not discuss pandas in this one note, rather than we will be moving on to directly on to Colab, as because it is very practical. एंड जब भी आप लोग पैंडा सीखने जा रहे हो, अगर आप इंटरमीडिएट लेवल पे हो या फिर बिगिनर लेवल पे हो, बिगिनर लेवल पे आप ज़्यादातर पैंडास यूज़ करोगे रेदर देन नमपाई. अब जब प्रो लेवल पे चले जाओगे मशीन लर्निंग या फिर डेटा एनालिसिस में, तभी आप लोग ज़्यादा नमपाई यूज़ करोगे रेदर देन पैंडास. But in this stage, when you are learning machine learning, when you are going through machine learning, in this stage you will be learning or you will be using pandas more, like almost 80% of the time you will be using pandas. Fine. So as because panda is also a kind of library, also a kind of framework, we will be importing it like how we have done for NumPy. So we will be doing the same thing, import pandas as pd. ओके, सो पीडी क्या है? पीडी हम लोग का पैंडा का एक निक नेम दिया गया है, एक निक नेम बस है. ओके, ना हम लोग पैंडा का काम क्या करेंगे, पैंडा में होगा क्या? पैंडा में हम लोग जो भी डेटा इंपोर्ट करेंगे, डेटा को लोकल सिस्टम से जो भी हम लोग कोलैब में लाएंगे, सब कुछ काम ये पैंडा के थ्रू ही होता है. हर एक काम pandas के थ्रू ही होता है. लाइक आप अगर इधर फाइल में जाओगे तो इधर फाइल में जाने से इधर एक अपलोड का बटन मिलेगा. So if you will be clicking this upload button, you will be redirected to your local files. Now just select your file which you want to import. Okay. So your file is imported in Colab. Now आप अगर इसमें जस्ट इंश्योरेंस डॉट सी एस बी में जब होवर करोगे आपको ये 3 डॉट्स नजर आएगा. ये 3 डॉट्स पे आप अगर क्लिक करोगे तो आपको एक ऑप्शन मिलेगा कॉपी पाथ. जस्ट क्लिक ऑन दिस कॉपी पाथ एंड आप लोग इधर फिर से आ जाना. एंड इधर आके आप लोग करोगे क्या, df इज इक्वल्स टू pd डॉट रीड csv. pd dot read csv. Okay, so basically what this function is doing, this function is reading your csv file from your local device, from your local storage. This function is reading, or this method is reading your csv file from your local device or local storage. Now आप क्या करोगे, आप जो चीज को कॉपी किए हो, जो पाथ को कॉपी किए हो वो जस्ट इधर पेस्ट कर दोगे. That's it. And your entire dataset will be in your Colab. Now run it. Now रन होने का बाद आप देखोगे कैसे कि क्या डेटा इंपोर्ट होके आया है हम लोग के पास, क्या डेटा इंपोर्ट हुआ है. सो आप लोग करोगे df.head. df.head एंड हेड एक मेथड है जो कि क्या काम में आएगा, जो आप लोग का जो डेटा सेट है उसका जो फर्स्ट 5 रोज है वो आपको डिस्प्ले होगा, वो ही बस आप लोग को डिस्प्ले होगा. रन कीजिए. तो रन करने के बाद आपको दिख रहा है, आपको कुछ कलम्स नजर में आ रहा है, कुछ कलम्स एंड रोज नजर में आ रहा है. एंड जो कि है एज, सेक्स, बीएमआई, बॉडी मास इंडेक्स, बेसिकली चिल्ड्रेन, स्मोकर, रीजियन, चार्जेस. फाइन. Now this is basically the insurance data set. This is basically the insurance data set. And what this head function is doing, head function is just importing the first 5 rows from the data set. And pd.readcsv is just a method which is importing the dataset from your local storage to Colab. Okay. Now suppose your file is in Excel format. What you will be writing? Simply in place of CSV you will be using Excel. In place of CSV you will be using Excel. Fine. Now suppose you want to visualize last 5 columns. What you will be writing? df.tail. You will be visualizing the last 5 columns. Now suppose these are the first 5 columns or last 5 columns. Now suppose you want to check random 5 columns from the entire dataset. You want to check random 5 columns, as because you will be getting an overall idea of the dataset. Because it may happen like if you are visualizing the first 5 column or the last 5 column, maybe there is some manual error or some syntactical error or some machine error or some sensor error that maybe it have done some mistake. Maybe if it is a manual, maybe if the data is collected manually, maybe that human at last he or she have collected or mentioned the data in a very biased way. Your data may be biased, so you may get a wrong idea or wrong intuition from the data, right? So let's go for random data. So for the random data, what you will be giving, you will be using one method known as sample. df.sample. df.sample. See, you are getting only one row. Why you are getting only one row? Because you have not specified how many row you want to see or how many row you want to visualize. Suppose I am mentioning 10. So you will be getting 10 rows. See, you are getting 10 rows, right? Now suppose you want to get the shape of the entire data. You want to get the shape of the entire data. Now this entire data is in the form of array. Just imagine this entire data set is in the form of array. Now you want to just look after that how many rows are there and how many columns are there. So what you will be doing, you will be using one NumPy method, that is shape. So you will be using df.shape. df.shape. See, now one thing I forgot to say, that is when the dataset is being imported to your Colab using Pandas, now your dataset is acting as a data frame. It is not a data set anymore, it is acting as a data frame, and that is why I have named this variable named as a df stands for data frame. Okay, you can give any name, but it is a standardized way how we normally name a data set or a data frame. Fine. Now suppose after you got the idea or the local intuition of the entire data set, you just want to get the information about the entire data set, that what is the age, how many null columns are there, how many columns are there, or null rows are there. You want to just visualize it. What you will be using? You will be using one method known as info, df.info. Okay, by this you will be getting all the informations. See, how many non-null columns are there, what is the count of it, what is the data type of each and every individual columns. You are getting everything. Now suppose you want to get the statistical summary, like what will be the average age, what is the maximum number of like what is the maximum number of people who are from male or female, like based on the gender you can visualize, based on the BMI you can visualize, everything you want to visualize in a statistical way. So basically you want to get the statistical summary. What you will be doing, you will be using one method known as describe, df.describe. Okay, now the describe method will be giving you the statistical summary. See, it is giving you the statistical summary like age, what is the mean, what is the average age, what is the standardization, what is the minimum age, what is the 25th percentile, everything it is giving in a statistical way. Now describe function and info function is very useful. Why? Because from this you can get to know that how many non-null columns or how many null columns are there in your entire data set. Fine. Now suppose you want to visualize that if there is any null values present in your dataset or not, exactly like in exact number you want to find. What you will be doing, you will be using one method df dot is null. Is null is basically checking if there is any null values present, dot sum. It will be summing all the null values for each and every individual columns. Now it is giving all 0. Why it is giving 0? Because there is no null value present in your entire dataset. Fine. Now suppose here I have used this shape method, and using this shape method you get to know that you are having 1338 rows, 1338 data, individual data you are having with 7 columns. Now suppose you want only first 10 columns or first 20 columns. Fine. So basically you are selecting some specific portion of the row, some specific portion of the dataset. What you will be doing? You will be selecting some rows. So for selecting the rows, you are having one method known as ilock, df.ilock. So what is ilock? Ilock means indexed based location. Okay, and here you are passing 0. Suppose here you are passing 0. So when you are passing 0, it will only give you the first row, it will only return you the first row. Suppose you want to get the value, suppose you want to get the value of first 5 rows, so 0 1 2 3 4, 0 1 2 3 4, you want to get these 5 values. What you will be doing? You will be using this thing df.ilock, and here you will be passing the starting index. What is the starting index? That is 0. What is the ending index? That is 4. But the ending index is excluding. As because the ending index is excluding, you will be passing 5 over here. Now it will be giving you all the rows from 0 to 4. See, it is giving you all the rows from 0 to 4, and in this way you can actually select a specific portion of your entire dataset and you can work on that. You can do whatever you want with that. Okay, now suppose you want to select a specific portion of the row and specific portion of the columns as well. A specific portion of the columns also you can select. Okay, so what you can do, df.ilock, and here you can pass 0 to 5, like you want to just only select 0 1 2 3 4, these 5 rows you want to select, and you want to select 0 1 2 3 4, that is up to smoker you want to select, up to smoker you want to select. So what you will be passing? 0 to 5 again. See, it is giving you all the values up to smoker, age to smoker, and 0 to 4. 5 rows and 5 columns it is giving. Now let us move on for LOC, that is level based indexing. label based indexing, that is, you can use the column names or the feature names. Column names are also known as the feature names. Remember this thing, this term will be very important when you will be going for the machine learning. In machine learning, we will not use the word column name, we will use features, okay, or variable names. Fine. So in label based indexing, what you can do, in label based indexing, you can use this thing, df.loc. Fine. Df.loc you are passing, and suppose you are passing up to 10, and here you are passing, suppose age you are passing, and suppose you are passing bmi, you are passing bmi, and you are passing smoker, you are passing smoker. Same, okay, here. And remember one thing, that everything is case sensitive. Everything is case sensitive. Whatever you will be writing, everything is case sensitive. It will give one error. Yeah, it will give one error. Rather than, what you can do is this. Still, it will give the error. Okay, wait. See, as because I forgot to give the square braces. Okay. What it is giving the error? None of them. Okay, sorry, I have not given the index number only. Like how many rows I want to select. I have not given the rows, and that is why it is giving the error. So suppose you want to select the only the first 5 rows, like 0 to 10. Okay, 0 to 10, like only 10 rows you want to select and put a comma, and after that you just mention all the columns, all the column names which you want to include in your data set, on which you want to perform the operations. Now just press shift enter. See, it is giving you first 10 values, but with the columns of age, bmi, and smoker only, as because you have used only the label names. So you can select the dataset with the basis of index number and with the basis of labels. Anything you can use. Fine. Now suppose you want to rename. Now suppose you want to rename. Suppose this age column is there. Okay, this age column is there, or this sex column is there. This sex column is, you want to replace this sex column with gender. You want to replace this sex column with gender. What you will be doing? uh, df dot rename. This rename is another method which is used for renaming your columns. Here you will be just using this name as columns is equals to, and here you will be passing curly braces. Inside the curly braces you will be writing which column you want, which column name you want to change. So you will be passing sex over here, and what is the new value, give the new value over here. The new value is what? New value is, suppose, gender. Okay, gender. Fine. Now if you just run it, columns, fine. Now if I run it, mm, okay, sorry, you have to give not is equals to, you have to give colon. It is in the form of dictionary, it is taking the dictionary. Yeah, now it is giving, see, age is replaced, and instead of age it is giving, sorry, instead of sex it is giving gender, right? Your column name is changed. Now suppose you want to drop one column, you want to drop one column, suppose you want to drop the region. Suppose you want to drop the region, what you will be writing? You will be using one method, df dot drop, and here you will be passing that column name, columns, 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 and inside it you will be passing that column name in list, only in list, region. Yeah, in small case, region. Now press enter. Now see, the region column is vanished. The region column is vanished. Even you can drop one row as well. You can drop one row as well. You can give, just give the index number, and it will drop that row. Suppose you want to drop that zeroth row, you want to drop the zeroth row. What you can write? You can just simply write, instead of columns is equals to region, you will be simply writing index is equals to 0. That specific row will get deleted. See, now the zeroth row is vanished. Fine, zeroth row is vanished. Now suppose here you don't have any such things, that where you are having null values. So if the null values will be there, when the null values will be there, we can use this method, that is how we can remove the missing values, how you can impute the missing values. Like suppose you are having in one specific row, you are having one missing value, how can you impute that. Now you guys will be asking that, sir, why do we have to replace the missing value? Why do we have to impute the missing value? The reason is very simple. That is, in machine learning, what happens that machine learning algorithms doesn't work at all whenever you will be having any missing value. The algorithm will stop then and there itself. The execution will not work at all. So you have to make sure that your entire data set is fully complete. No single missing value will be accepted by any machine learning algorithm. So you should make sure of that. So when you will be going through the EDA, at that point of time I will go through this method of this imputation by mean, median and mode. I will show you that. But as because this data set is not having any missing value, so you can learn it later, not an issue. And there are more few methods are there, like filtering, group by, then sorting, then how to remove the duplicate values, like the redundant values. All these things we, or the unique values are also there, yeah. So all these things we will be learning in the upcoming videos. Why? Because we should learn these things as per me, uh, like, because I am giving training for a lot of years, so that's why I am saying with my experience that students often confuse if they are learning these unique values in a very consistent way. So better you should learn in a project basis, like when you will be doing the project based on the questions, you will be learning all these things. With the questions we will be solving those things, we will be learning new things, and we will be solving the questions as well. Okay, so that's it all about the pandas. This is the basic of panda I have given, basic syntax, basic methods of pandas I have said in this video. Fine, we will directly start in our Colab, and in this video we will also go through the Seaborn and why Seaborn is essential for us. Fine. Now, before starting with the data set and all, let me give you one brief introduction. Let me tell one brief introduction about the Seaborn. So, why Seaborn is essential? See, Seaborn is one visualization library which is available in Python, which is used for making all the visual plots and data charts in our Colab. Now, why these things are essential? See, whenever you will be doing the data analysis, you will be preparing some report, you will be going through some codes in Colab. Now, whatever you are getting, whatever the outcomes you are getting, whatever you are understanding from the data set, like whatever like ideologies you are getting from the data set, or whatever intuitions you are getting from the data set, you have to convey to your managers who may be from the non-tech background or who may be from the tech background, whatever. But you have to give the presentation on what you are understanding from the data set. But suppose in some point of time you are not getting all those kinds of report directly, like to the points you are not getting, you are getting by some codes. How can you show them? Because maybe they belong from tech background, maybe they belong from non-tech background, they cannot understand your Python codes, all those Python codes. So you have to show them some visual representation, like some bar plots, some box plots, some histoplots, histogram plots, all these things you have to show them, right? So for making all those things based on your data set, based on your analysis, based on your analytical reports, you need this Seaborn. Now you can use the Matplotlib as well. Someone will be commenting down that sir, why you are not using the Matplotlib? See, Matplotlib also we can use, but with Matplotlib, the number of lines of instructions will get a bit high. Yeah, but using Matplotlib, things are very customizable. But Seaborn, I think Seaborn is much easier in the beginner level as well as in the advanced level as well. Like Seaborn is very easy to learn and very easy to work. It is not like if you are working with Seaborn, you cannot work with Matplotlib. It's not like that. But the syntactical things are very less in Seaborn. That is why I will be preferring Seaborn. Fine. So let us first import all the data sets. Uh, for this video, I will be using the tips dataset which is available in Seaborn. First of all, we have to import all the libraries, right? In the previous video, we have gone through NumPy and Pandas. If you have not gone through that video, please go through that video at first, then come to this video. Otherwise, the things will be very hectic for you. So we have to first import the NumPy library, then we have to import the Pandas library. Fine. Pandas as PD. Now this I have told you that this NP and PD are nothing but they are simple allies we are using. That's the nickname of NumPy and Pandas we are using. Now we will be learning, I have said that we will be learning about the Seaborn. Now we have to import the Seaborn as well because it is also one of the library. Now we will be importing the Seaborn, import Seaborn as SNS. Fine. Now let me say you one thing, that Seaborn is such kind of library, or you can say framework, which is having its own dataset, which is having some of its own dataset, and it is basically meant for the practice purpose. Fine. Now we can use those dataset for the learning basis, for the learning purpose we can use those dataset. Now how can we access those Seaborn dataset? See, df is equals to SNS. SNS is basically this alias we are using for the Seaborn. Fine. df dot sns dot load dataset. So this load dataset is one method in Seaborn which is useful for importing the dataset of the Seaborn in our Colab file as a data frame. Fine. So we will be importing the entire dataset. And what dataset we will be importing? We will be importing tips dataset. We will be importing tips dataset. Data sns dot load dataset. Okay, there is one spelling mistake I have done. Dataset. Yeah, now it will run. Now if I just do df dot head, I have told you already that what is the purpose of df dot head. It is basically, it will be just giving you all the 5 rows from the first 5 rows of the dataset. It will be just giving you the visualization of first 5 rows from the dataset. See it? So we are having some columns like total bill, like what is the total bill given by the customer or generated by the customer. What is the tip? Basically in the restaurants some tips are given, right? So this is the tips. Then what is the gender, that is the sex given over here. Whether the specific customer is a smoker or a non-smoker, then which uh, day they have went to that restaurant, and what is the time they have went, and what is the size, like with how many members they have went to that restaurant. This is all about our data set. Now this is our basic understanding or the overview of the data set. Fine. Now from this data set we have to understand that how many rows are present in this data set. So for understanding how many rows are present, we have to go through one method that is available in NumPy, that is SAPE, for understanding what is the how many individual data are present in this entire data set. So we will be going through df dot SAPE. By this we can understand how many rows are present. See, we have 244 rows and 7 columns are there. So we have 244 individual data are present. 244 individual data are present. Okay. Now we just want to get what are the data types and how many, like we just want to get the overall information. We just want to get the overall information from this data set, like how many non-null columns are there, how many null columns are there, or null values are there. We just want to get through that. So we will be going through df dot info. We will be getting an overall information about this data set. Now see, so we are getting what, total bill. uh, okay, so there is no non-null columns are present. That is great. No non-null columns are present, and we can also get the individual data types for those, for the entire column, individual data types for all the columns. Okay, now we just want to get that are there, I am writing down the question, are there any missing values present in the data set? Are there any missing value present? We can get that we from this info only we can get that there is no null data present in the dataset, but still we are going through it. Are there any missing value present in the dataset? In the dataset. So let us check that. So for that we will be going through df dot is null. So is null is basically checking how many null columns or null values present in your dataset, and we just want to get the entire sum up of all the null values. So we will be going through df dot is null dot sum. It is reconnecting, just a second. Okay, so basically we will be going through this df dot is null dot sum, and it will be giving you the sum of all the reports, all the null values. See, we don't have any null value, and that is why it is giving us 0 for every columns. Now we just want to check that whether there are any duplicate rows or duplicate data, and if we go more technical way, if there is any redundant data or redundant redundant row present in our dataset, we want to check that. So are there any duplicate rows? For checking of the duplicate, we will be using one method known as duplicated. So we will be going through df dot duplicated dot sum. Okay, we will be summing up the entire thing. Df dot duplicated dot sum. So there is only one duplicate row present. Fine. Now, in the previous video, I have told you that our machine learning models will not work if we have any null value, right? If we have any null value, our machine learning models will not run. It will stop then and there itself. But the factor is, whenever we will be going through data analysis, whenever we are doing the reports, we are preparing for the reports during the data analysis, we will not do any data cleaning or feature engineering process. Like, we will not impute the data set like any null values. Why? Because the thing is, see, whenever you will be modifying anything, or when you will be imputing the null values, imputing means you will be just replacing the null values with something. Like, we will be learning afterwards how you will be like replacing the null values or imputing the null values. There are some techniques are there by which we will be doing that. But or you will be removing the duplicate rows. You should not do all these things. Why you should not do? Because whenever you will be preparing those analytical reports or MIS for some companies or for some organization or for your own job, uh, it will be a case of data tampering. Like, if you do before preparing the MIS, if you just impute the null values before preparing all those analytical reports, it will be a case of data tampering. You are just playing with the raw data. So that is why I am saying that you should not, note it down carefully, you should not do any kind of feature engineering techniques before you prepare your analytical reports. Fine. Now, we have seen how to get the duplicate rows in our entire dataset, from our entire dataset. Now, what will be our numerical summary of the entire dataset? What will be our numerical summary? So we can get the numerical summary using the method of describe. df.describe. See, we are getting the numerical summary, like individual count, mean, standard deviation, minimum, maximum, everything we are getting from this. Okay. Now let's get one simple idea about the EDA. What is EDA? EDA means exploratory data analysis, and this is done by the data analyst. Data analysts are doing what? They are understanding the psychology and the mentality of the dataset. They are going deep down through the datasets. Before they start analyzing any data, they observe the dataset at first. So you have to observe the dataset before touching your computers, before touching your keyboard, before touching your mouse. You should observe your entire dataset for at least 1 to 2 hours, and then we should go on for the EDA techniques. And what all things you will be observing, everything will be based on your intuition. Fine. Now we will be learning EDA today with the help of univariate and bivariate and multivariate analysis. Okay. Now, what is meant by univariate analysis? First of all, let us start with that. What is univariate analysis? Let us start with this. Univariate analysis. So what is meant by univariate analysis? So univariate analysis is a process of analyzing one variable at a time. Like, you will be analyzing a single column at a time, only single column, whatever the column it is, you will be analyzing only one column. Okay. Now, after you analyze, you will have to go through each data type. You will have to analyze whether it is categorical data or numerical data, whatever it is, you have to analyze through it. Okay. Now, as we will be moving ahead, we will be understanding each and every concepts deeply by solving one questions, so that you can get the proper idea of each and every techniques. Okay, so I have told you about the univariate analysis. Now, based on this data set, we will be doing all those univariate analysis. Now let us first do one thing. Let us do this head method once again to visualize this entire data set again. So what are the columns we are having? This 7 columns we are having: total bill, tip, sex, smoker, day, time, size. Okay, now univariate analysis, what does it mean by? We will be analyzing only one column or one variable at a time. Now I am giving you one example from this data set. Suppose I am asking you which gender has more customers. Which gender has more customers? Now see, just check it down that we are analyzing only one column, that I want to figure it out that how many genders, like which gender from this sex column is more, like whether female is more or male are more. Like in some specific restaurant, I want to analyze whether female customers are more or male customers are more. I want to analyze this. So for this, what we will be going through, we will be going through one technique. See, I am writing down the question at first. We will be analyzing the gender column at first. We will be analyzing the gender column, as because we are doing the univariate analysis, we will be doing it. I just want to figure it out that how many male customers are there and how many female customers are there. So for this, we will be having one method known as value counts. You can see that this AI is also giving this thing. Whatever, don't look at it. Just write your own code. df undercode, just write it down, sex dot value counts. Value counts. Okay. So with this, you will be getting the exact number that how many male customers are there and how many female customers are there. So you can include this thing in your analytical report. Now, see, you have got the report, that is fine. You have got the exact value, exact figures you have got, that is very fine. But you cannot give this kind of thing in your report, or you cannot show this kind of thing in your report. What you have to show? You have to show the visualization charts. You have to show the visualization chart. So for this, you will have to use something, that is, we will be using sns dot count plot. We will be using sns dot count plot, and here we will be going through like data is equals to df. Like first of all, you have to give the data. First of all, you have to give the data, and where the data is stored, the data is stored with the name of df. You have to give the entire data set at first. Then you have to give the x variable. You have to give the x variable, as because you don't have to give the y variable. Y variable will be your count. Y will be your count, and it will be taken automatically, as because you are using the count plot, it will be taken automatically. X column will be sex. X column will be your sex. Now just run it down. Just see the chart. See, you are getting the visualization report. Now this count plot is one method which is available in your Seaborn framework. Okay. Now you can got it down that how you will be doing the univariate analysis. Now let us move on for the next question. Let us solve more questions so that you can understand more about the univariate analysis. Now from this data set, I want to figure out that are most customers smokers or non-smokers. We want to analyze that most customers are smokers or they are non-smokers. So for that, again, we will be writing same kind of things, same kind of command we will be giving, df, and under it you will be writing smoker. Mention one thing that everything are case sensitive. Okay, note it down carefully. Everything are case sensitive. Value counts, COUNTS. Okay. Now check it down. Okay, so the most of the customers are non-smokers. From here you can get it down that most of the customers are non-smokers. Fine. Now you have to visualize it as well. So what you will be doing, you will be going through the same command, sns dot count plot. And here you will be giving, first you will be passing the entire data frame. Entire data frame you have passed as a data, and you will be passing the x column, that will be smoker. That will be smoker. Now check it down. In the x column we are having the smokers, yes or no, and in the y column we are having the count, number of counts we are having. Got it? In this way we can visualize the thing. Now coming to the third question. Third question is, we will be analyzing, let us move on through the data set once again. Which day has the highest number of customers? Which day of the week have the highest number of customers? We want to figure it out. Which day of the week will be having the highest number of customers? Okay, so basically this count plot is doing what? It will be going through each and every row of the column, each and every row of the column, specific column, and it will just count it down. It will count that how many Sundays are present, how many Mondays are present, how many Tuesdays are present. It will be counting through each and every rows. Basically inside the count plot, it is going through a looping procedure. Under it, it will be using some while loop or for loop it will be using, and it will be going through all the data. Okay, now let us go through this question. Which day has the highest number of customers? So same thing we will be writing df, under it we'll be writing day dot value counts. Same thing. See, it is giving the data for each and every day. Now the thing is, we have to go through the visualization of it, right? So for the visualization, again we will be using the count plot. Now you must be thinking that Sir is continuously showing us about the count plot. Now why we are using the count plot? Because when we will be doing the univariate analysis, in univariate analysis, mostly we go through the count plot or pie chart. There are only two plots which we will be going for the univariate analysis of the like, I mean, not actually like when we will be having only the categorical data. Like since starting we are analyzing the categorical data, right? Categorical data means like yes or no, sex like male or female, then the day, Sunday, Monday, what day is there. So whenever we will be doing the univariate analysis of the categorical data, we will be using only two plots, that is the count plot and the pie chart. Remember this thing, because students will get confused that what chart or what plot we can use at what point of time. So I have said that whenever we will be using whenever we will be doing the univariate analysis of the categorical data, we will be using the count plot or the pie chart. Fine, let us run it. See, we are getting the data for like in the x-axis we are having the day, Thursday, Friday, Saturday and Sunday, and in the y-axis we are having the counts. Fine. Now let us solve the next question. The next question will be, which day has the lowest number of customers? Let us move on through this data set. Which day has the lowest number of customers? See, which day have the lowest number of customers? Obviously by this graph only we can say that Friday is the day which is having the lowest number of customer. Friday is the day which is having the lowest number of customer. Now with the help of this value count, we are getting all records for all the days, like Saturday, Sunday, Thursday and Friday. We are getting the records for all the days. Now we want the exact figure Friday. We want the exact figure of the day on which we are having the lowest number of customers. Fine. For that, what we will be doing, df dot value counts, and then we will be doing dot mean. We will be doing dot mean. We are finding the minimum value. Sorry, df dot value, wait, not df dot value count, actually df, here we will be passing the day dot value counts, and here we will be passing the minimum. See, 19 it is giving. So which is the day? Friday is the day which is having the lowest number of customers. Or here you can pass idx mean. It is giving Friday. Okay, now if you want the exact weekday, you have to give idx mean. Now you can go for the visualization as well with the same way how I have shown. Now let us again move on through the data set. In the data set, the next question we can solve is, do more customers visit during lunch or dinner? We want to analyze the time. Now we can analyze the time as well. Do more customers are visiting during the lunch or the dinner time? What we will be doing, df time we will be passing dot value counts. Okay, now see, we can figure it out that most of the customers we are having during dinner and very less customers we are having during lunch, and it is almost less than 50%. right? The difference is a 50%. Now we can do the same way of visualization using the count plot for this question as well. So we have analyzed, if you have seen carefully, that we have analyzed each and every categorical columns like sex, smoker, day and time. Now let us analyze the numerical column as well. Let us go for the numerical column as well for the univariate analysis. Okay, so for the numerical analysis, what can be our first question? We can analyze the total bill. Like what can be the average bill? What can be the average bill made by the specific restaurant? What will be the average bill made by the specific restaurant? So what I will be doing? Df dot, not df dot. Yeah, you can write in this way as well. You know, you can write in this way as well. You can write df dot total bill, like without giving those data frame, without using the pandas way for writing the thing. You can use like this: df dot total bill dot mean. That is the average we are getting. We are finding the average of the total bill. See, it is giving the average, but it is giving in NumPy format. It is giving in NumPy format. See, it is written as np.float. Right now, if we want in the normal data frame format, then we have to write this total bill or the column name inside the square brackets. df total bill, and we will be writing dot mean. See, okay. Now, how to visualize it? Let us go on for the visualization. Now we are analyzing the numerical data. Total bill is the numerical data. We are analyzing the numerical data. For analyzing the numerical data, you should keep one thing in your mind. We will be using histogram, dist plot or box plot. Histogram, I am writing it down. For numerical analysis, we will be using histogram, dist plot, or we can use box plot. Okay, and for the categorical analysis of the numerical of the univariate data, when we will be doing the category, when we will be dealing with categorical data, that time we will be doing categorical. That time we will be using either count plot or we will be using pie chart. Fine. Now let us see the visualization for it, as because we have gone for the numerical data. So now let us move on for the visualization. So for visualization, what we will be using over here, we can use histogram plot. As because it is the numerical data. SNS.histplot. Inside the data, we will be passing df, and in the x-axis, we will be passing the total bill. Now check it down. What we have got in the total bill dot mean, what is the average bill the customers have spent? $19.78. And remember one thing, that if you seen this data set carefully, the tips are given in one digit, right? 1.01, 1.66. These are not in rupees, these are in dollars. Okay, remember this thing. Now what is the average total bill? We are getting $19.78. Now when we will be doing the histogram plot, when we will be finding out the histogram plot, we are getting it that the average is around somewhat $19, somewhat around the $19. Fine. So the numerical answer gives the average bill, while the histogram shows the complete distribution. Okay, histogram shows the complete distribution. Okay, now we want to find that what is the highest total bill customer have paid. So the same way we can write df total bill, and we will be writing dot max. There is one method known as max. See, the highest bill is $50.81. $50.81. Okay. Now this type of questions where we are finding the maximum value and minimum value only by one statement, for this we don't need to go for the visualization. That is absolutely lame kind of thing we will be doing. Now if we want to find out the maximum, we can figure it out for the entire data set. For the entire data set we can figure it out for the visualization, but for the single value we should not go for the visualization. It is not needed. Now in the same way we can go for the lowest bill, lowest total bill, right? Now let us go on again with the data set. What can be the next data or next column we can analyze? That is the tip data set. What is the average tip given by the customer? df tip dot mean. Then we are getting the average tip, that is the $2.99. $2.99, that is the average tip. And what will be the maximum tip then? df dot tip dot max. What is the maximum tip people have given? That is $10. $10 people have given for the tips, and that is approximately 900 rupees. Yeah, 940 rupees kind of. In the same way you can find the lowest tip as well. Now by analyzing the data set, what can be the next possible question? Now what will be the most common table size? What will be the most common table size? Most common table size means, like I want to find out that I want to find out the majority, that the majority of the people have booked for what size of the table, like 2, 3, 4, what size of the table they had booked. I want to find majority, like most common people, like commonly people are booking for what table size. That is the thing I want to find out. So what is, this question is very important and tricky as well. This is very frequently asked in the interviews. If you are preparing for the interviews, this question will be very, very important. What is the most common table size? What will be the most column table size? And that is why, as because the question is important, that is why I have written down the question. Now from this, what normally you will be doing, you will be going for df. See, I am writing df size, and what you will be doing normally is max. Most of the people you will be doing is max. You are getting 6, but max is giving you what? That only one customer, maybe only 1 or 2 customers out of 234 records, maybe 1 or 2 customers have booked the table for 6 members. For 6 members, it is giving you only that value. But I want to find out that, like commonly, what the size of the people, what the size of the table that people are booking. So for the common one, like which is occurring at the majority, which, what is the, I just want to find out the highest frequency. I want to find out the highest frequency in the size column, which number is occurring very frequently. So for that frequency, maximum frequency, I will be using mode. Okay, because mode is the one which is going for the frequency, which is finding out the frequency. So df and here I will be writing size, and if I do go for mode, it will be giving me that. It is mostly people are booking for 2, like 2 table size, like when the, like they are booking for a table which will be consisting of 2 members only, because mode is the one which will be giving me the highest frequency, like the number which is occurring the most, the value which is occurring the most, it will be giving me that. Okay, now that is all about the univariate analysis. Now we will be going for the bivariate analysis. Now in bivariate analysis, we will be going for multiple things. Bivariate and multivariate, almost they kind of thing, they are kind of the same thing. Okay, now let us move on for bivariate analysis. Bivariate analysis. Okay, okay. So in bivariate analysis means analyzing the relationship between two variables. Analyzing the relationship between two variables. Okay, So in bivariate and multivariate analysis, you have to go through few things which you need to keep in your mind. You have to go through few things. I am writing it down in the OneNote. Bivariate analysis. Bivariate analysis. So in bivariate analysis, you have to keep few things in your mind. So few things are, see, bivariate analysis means analyzing the relationship between two variables. So means here we are using two columns, or we are analyzing two columns at a time. Here we are analyzing two columns at a time. Now these two columns, maybe one column may be numerical, one column may be numerical, another column is also numerical. It may happen. This can be the possible combination. Or it may happen one column is numerical and another column is categorical. This combination may also happen, categorical. Or it may happen both the columns are categorical. Both the columns are categorical. This may happen, right? Now, one thing you should keep in your mind, that is, for numerical analysis, when both the columns or when both the variables are numerical, what are the plots or what are the charts we will be using for visualization? Remember these things, because these things will be very essential when we will be going for on, when you will be going in your job, or you will be sitting for the interview. For both the cases, this will be very important, and these things you should have to keep in your mind. Like it should be dissolved in your blood, like that. Numerical analysis, what type of plot you will be using? You will be using scatter plot, or you will be using line plot based on the situation. Okay, like for both the cases, both the plots may work. It may work. Like 99% of the cases, for both the numerical columns, either of the plots it will work. For numerical categorical analysis, like one column is numerical, another column is categorical, that time you will be using bar plot, box plot, or dished plot. Bar plot, box plot, or dished plot. Okay, for categorical analysis, like both the columns are categorical, you will be using heat map, or you will be using cluster map, or you will be using cluster map. Okay, I hope you have understood this. Now let us again move on to the Colab. First of all, let us visualize this. Let us visualize the dataset once again. That what are the questions or what are the combinations we can find out for numerical analysis. First of all, we will be going through numerical analysis, and we will be learning scatter plot and line plot. Total bill, we are having tip, sex, smoker, day, time, and size. Fine. So numerical analysis, both the columns, that is x axis and y axis, both will be of numerical data. Both will be of numerical data. Now, first question from this data set, we can find out that is the total bill related to tip? Is the total bill related to tip? Okay, I have forgot to put the hashtag, comment it down. Okay, is the total bill related to tip? I want to figure it out that when the total bill increases, tip is also increasing, or it is not increasing, it is like that itself, like it is not at all relatable with the total bill. I just want to figure it down. So for finding it down, what we will be doing, we will be using as because first of all we have to go through the direct solution as well. Before the visualization, we have to get the direct solution as well. So what we will be doing, df, and here we are analyzing, as because we are analyzing both the column, so we will be writing df total bill. Total bill we will be passing over here, df total bill. I want to figure it out that whether there is any relation. What I have written the question is the total bill related to the tip. So I just want to find out the relation, whether there is any relation between the total bill and tip, like with the increasing of the tip, whether the tip is increasing or not. So for that we will be using one method known as CORR. So it is finding out what? It is finding out the correlation between both the columns. It will be finding out the correlation between both the columns. So if you just want to figure it out that what is correlation, I am just giving you four graphs. I'm just giving you four graphs. Suppose this is one graph, this is x-axis and this is y-axis. Suppose we are having this line. Suppose we are having this line. So this is what? Positive correlation. With the increasing of x, y is also increasing. This is what? This will be negative correlation. Okay, this will be negative correlation. This is what? This is constant. This is going constant. With the increasing of x, y is remaining constant. Okay, or the graph may behave like this. With the increasing of y, x is at a constant position. Or data may be clustered like this. Data may be clustered like this, where there will be no correlation at all. So here we will be using one method known as CORR. It is basically finding out the correlation between both the columns. CORR, sorry. Here I will be passing df tip. We are passing the tip column. Let's see that. It is giving me 0.67. So here we are getting the value as 0.67. So there is one range of correlation that when we are having the correlation value from 0.5 to 0 from 1, like what is the range of the correlation? -1 to +1. Basically -1 to +1 will be the range of correlation. So whenever we will be having some value, we will be getting the value like beyond, like after 0.5 to, like from 0.5 to +1, that means it is very strong correlation, like strong to, like moderate to strong correlation we are getting. Okay, whenever we are getting some value close to -1, that means we are getting close to negative correlation, like no dependency is there, no relation is there between two columns. Now here we are getting the value as 0.67. that means we are getting moderate to strong relation between the total bill and tips. So that means a very good relation is there, a very good dependency is there of the total bill on the tip column. Okay, now how can I visualize it? How can I visualize it? We can visualize it with the help of scatter plot, as because it is numerical analysis. So SNS dot scatter plot, and here first of all I have to take the data set. So data is equals to df, and in the x-axis what I will be writing? I will be writing the total bill. I will be writing the total bill. You can write anything, but as because we are finding the dependency of the tip on total bill, we are finding the dependency of tip on total bill, that is why we are writing this total bill in x-axis and tip in y-axis. Check it down. Okay, now suppose we are doing the line plot. We are doing the line plot for this entire, for exact same data. SNS dot line plot, and if I do data is equals to df, and x-axis will be total bill, x-axis will be total bill, and y-axis will be tip. What it will be generating? See, it is kind of linear. It is kind of linear. Positive correlation it is giving, increasing, like along with the increasing of total bill, tip is also increasing. By this scatter plot, things are not getting very clear. It is very scattered, actually, very scattered, messed up data. But by the line plot, things are getting cleared. With the increasing total bill, the tips are also increasing. The person who have paid $50, they have paid the tips of, like, person who have the total bill of $50, they have the total bill of $10. So yeah, we can say that along with the increasing of total bill, the tip is also increasing. Now let us move on for the second question. The second question will be, let me figure it out from the dataset itself. How does the average tip change the total bill range? How does the average tip change the total bill range? No, it is also kind of same question. Let me think something different. Is the table size related to the total bill? Next question will be, is the table size related to the total bill? Is the table size related to the total bill? Like, I want to find out that whether the size of the, with the increasing size of the table, the total bill is also increasing. I want to figure it out that thing. So here also we will be using the correlation only, right? And both the columns are numerical. So df size, we will be writing dot corr, and here we will be passing total bill, df total bill. Let it run. So we are getting 0.59. Okay, so it is above 0.5. So it is, as because it is above 0.5 and it is close to +1, we can say that there is a moderate to strong kind of correlation or relation is there in between table size and total bill. Okay, now how can I visualize it? Using the same scatter plot, and or you can use the line plot, using the same scatter plot or line plot. Okay, now let us move on to the next question. The next question will be, how does let me frame the question. Yeah, how does the average total bill change with the table size? How does the average total bill changes with the table size? Now we are not finding out the relation over here. We got it that there is the relation between the total bill and size. We got it. There is the correlation, there is the positive correlation is there with the total bill and size, that we got. But now we want to figure it out that how does the total average total bill change with the table size? How does the average total bill, let me write down the question. Let me write down the question. How does the average total bill changes with the table size? Fine. This is the question. Now for this question, we have to use a very important and interesting thing. It is very important in the entire data analytics concept. Like, if you have gone through the SQL also, then you have learned, or you have gone through one method known as GroupBy. So this is the question of GroupBy, and here I am giving you a live example of GroupBy, because I have not covered GroupBy in the Pandas video. Why I have not covered? Because I wanted to show you, or I wanted to explain GroupBy in a practical way. In a practical way, I wanted to explain this GroupBy. First of all, you have to understand what is GroupBy. GroupBy, think of GroupBy as it is first dividing the data into groups, and then it is performing calculations on each and every groups. It is first dividing the data into groups. It is first dividing the data into groups, and then it is performing calculations on each and every group. Now let me write it down in OneNote, because things are, you have to understand the thing. You have to understand this thing. What is GroupBy? And it is very important for the interview perspective or for the job perspective. It is very important. GroupBy. Okay, so what is GroupBy? Think of GroupBy like it is first dividing the data. It is first dividing the data into groups, then it is performing, then it is performing calculations on each group. Calculations on each group. Now I know that the things are not getting cleared by this definition. This is just a theoretical definition. So I just wanted to make you understand by this example, by this question which I have given just now, that how does the average total bill change with the table size. Now as because you have gone through this data set for a long time, if you are watching this video till this time, so you already have gone through many questions, right? You have gone through this data set multiple number of times. So I guess the data set is now in your blood. So by this example, we will understand. Now, what does the GroupBy is doing? GroupBy is splitting the data at first, then it is applying some functions, and then it will combine the data again. It will combine the data again. Okay. Now, this is the entire flow of GroupBy. Now, let me solve that question. Sorry. The question was, how does the average total bill, how does the average total bill change with table size, changes with table size, changes with table size. Okay. So for table 1, for tables having 1%, 2%, 3%, etc., what is the average restaurant bill it is generating? This is what we want to find. From this question, what we want to find for tables having 1%, 2, like 1%, 2 people, 1%, 3 people, like this, what is the average restaurant bill we want to find out. Okay. Now for this question, what will be the answer? Like how can I write the answer? So df dot group by, if I write df dot group by, and group by we will be writing like this: group by what we want to group by, what we want to group by. I want to group by size, like I want to figure it out that with the average total bill, how this table size is changing. Sorry, vice versa, with the increasing table size, how this average total bill is changing. So I want to group by the size. I want to group by the size. What are the sizes? Like 2, 3, 4, 5, like these sizes I want to group by it, and I want to find the average total bill, that how it is getting changed. Size I will be writing, and then I will be writing the total bill. Like this is how the group by is written. This is the syntax. Total bill. What we want to, first of all, what we want to group by. Here I will be writing what we want to group by, with what perspective, with what perspective. Okay. Now group by always works with some aggregate functions. Remember this thing, group by always works with some aggregate function. I want to find out how the tables, how the average total bill is changing with the table size. Average total bill, this is the aggregate function. This is the aggregate function. Okay. Dot mean, this is the aggregate function. Now what does this group by size is doing? It first groups all the rows according to the table size. It first groups all the rows according to the table size. Try to understand it deeply. First the size is 2, suppose. First the size is 2. When the table size is 2, what are the total bill we are having? What is the total bill? The total bill is like 16.99. For the table size 2, what are the total bill we are having, normally getting? $16.99 or $18.20 or $22.50 or $20.10. Now these all data belongs for the table size of 2. This all data belongs for the table size of 2. For size 3, for size 3, size 3 group by function will be grouping again for the total bill. For the total bill, it may be 10.34, 11.12. I am just taking the random values. Okay, I'm not referring any data set. I'm just taking the random value for your understanding. 24.03, like this it may give. Okay, now these people belong from the table 3. Now what does this total bill is doing? Total bill dot mean is doing. What does this total bill dot mean is doing? It is doing the average for all the data. It is doing the average for all the data. For size 2, we are grouping the total bill and we are taking the average of the total bill. Like suppose average we are getting by looking at this data set, we can figure it out. The average will be somewhat around 19.20. It is just a random guess I am taken. Okay, suppose the average is 19.20. Now for the size 2, for the table size 2, the average average total bill will be 19.20. For the table size 3, the average total bill will be somewhat somewhat around 15.20. Now what this group by size is doing? Group by size is grouping the total bill based on the table size, based on each table size. What are the table sizes we are having? 2, 3, 4, 5, like this we are having up to 6. So it is grouping the table sizes for each and every individual sizes, and after that it is finding out the average total bill. Now group by function always works with this aggregate functions. If there is no aggregate function, it will give one error. Now I hope it is clear for you. Now let us move on to Colab once again. Okay, now let us solve it. Let us solve it. Df dot group by, if I give group by, and what I will be grouping by? First of all, size. Based on the size, I am grouping by the total bill. Total bill. Okay, with mean. And remember this thing very carefully, that always group by is taking the aggregate function at the end. See, for table size of 1, it is taking what is the average total bill, that is 7.24. For the table size of 2, what is the average total bill, that is 16.44. Like this it will work. Now coming to numerical categorical analysis. Like one column will be numerical, another column will be categorical. Numerical categorical analysis. Numerical categorical analysis. Fine. Now for numerical categorical analysis, first question we may do is, let me figure it out. Okay, which gender has the highest average total bill? Which gender has the highest average total bill? So this is also one of the question belongs from the group by. Which gender has the highest average total bill? Let me write down the question. Which gender has the highest average total bill? Okay, which gender has the highest average total bill? So for, okay, it is already predicting the thing. Don't look at it, just try to analyze the dataset at first. What I want to figure it out, that based on the gender, so what I want to group by? Based on the gender, as because I am saying I want to group by the gender. I want to group by gender, that is sex column. That female, for female, what is the total average? Like what will be my question? Which gender has the highest average total bill? This is what I want to find out. Now if I break down this statement, which gender has highest average total bill, that means I want to figure it down, that for female what is the highest average total bill, and for male what is the highest average total bill. So now just say that what I want to group by. I want to group the sex column. I want to group the sex column. For the previous question, I have grouped the size for table 1, table size of 1, for table size of 2, for table size of 3. For this question, for sex male, for sex female. Got it, I guess. So df dot group by. Inside group by, I will be passing sex. Okay. And here what I want to figure it out, I want to find out that based on the sex, what is my average total bill? What is my average total bill? So here I will be passing total bill dot mean. Okay. See, it is giving for both the columns. It is giving for both the columns. Now just say that as because this is a numerical categorical analysis, and for numerical categorical analysis, we will be doing the visualization using bar plot, box plot, or dist plot. Okay. Now we will be doing this with better. This will be for the bar plot. This will be better in case of the bar plot. Why bar plot? Because bar plot, as because we are having only two distinct sex values, right? Male and female. And that is why we will be using bar plot, because bar plot will be representing it in a more better way. When you will be doing it, practicing it over time, the things will be going in your blood. It will be dissolved in your blood. Like which things would we use? Like we are having only two sex columns, like male or female, only two are there. So in this case, we will be using the bar plot. That will be looking better. It will be giving better visualization. df not df sorry sns dot bar plot, sns dot bar plot. Here I will be passing data is equals to df, and in the x column I will be passing sex, and in the y column, remember this thing is a numerical categorical analysis, I will be passing total bill. Check it down. It is giving a better representation. Now if I do the same thing using the box plot, box plot will also work. Box plot will also work. Yeah, bar plot and box plot, right? Box plot will also work over here. Yeah, it is also working fine. It is also giving a proper visualization. But if you use a dist plot, that is distribution plot, kde, it is giving you the kernel density estimator. That thing will not work in a better way. That thing will not work in a better way, because what the kde plot is giving you, what is the visualization it is giving? It is giving you like KDE plot or a dist plot is a combination of histogram along with a smooth curve, and it will be giving you kernel density estimation. Okay, so what is the insight you will be getting from dist plot? You will be getting a representation of the probability density function. It tells you the probability of a random value being equal to something. It gives you the probability basically. That time you will be using the KDE plot. I guess it is clear. So if you use the dist plot over here, sns dot dist plot, and if you use data is equals to df, and if you pass total bill, sorry, total bill, see what is the thing it will be giving. What one argument data. Okay, the dist plot is not working. It is giving some error. Na? Okay, fine. I have done some mistake in the syntax of the dist plot. So what is the syntax? Syntax will be working like this. It will not, unlike other plots, unlike other graphs, it will not take data is equals to df or x. Like in the x-axis I will be writing this, in the y-axis I will be writing that. We don't have to do all these things. Rather than we will be directly writing df answer, under this square braces we will be giving this total bill. Okay, now check, it is giving the distribution plot. Fine. Now from this plot, from this kernel density estimation plot, what is the thing you are figuring out? You can figure out that whether your graph, whether your data specific column is following the normal distribution or it is not. like whether your data is having a normal curve or not normal curve, it is having a bell shaped curve or a not bell shaped curve, it is having some skewed data. You can figure it out that. Now that is a part of feature engineering, I will be explaining it later, but as of now, just try to understand that a disk plot is a distribution plot which is helping us to understand whether a specific column is having a normal curve or a not normal curve, because it will be helping us to check that whether our specific column is having outliers or not outliers or no outliers. Okay, now what is an outlier, that I will be discussing it in the feature engineering, it is not a part of data analysis. Okay, now let us move on with the next question, that is, I'm writing down the question: do smokers or non-smokers have a higher average total bill? Have a higher average total bill? Have a higher average total bill? Okay, do smokers or non-smokers have a higher average total bill? Now, how many smokers we are having? Like, what we want to find out? First, let us see that what we want to find out from this question. We want to find out that smokers are having a higher average total bill or non-smokers are having a higher average total bill. So basically what we want to find out in the smokers column, if we look carefully, what are the values we are having? The values we are having is either yes or no, either yes or no. So what we want to find out for smoker column, if the specific person is a smoker, he is having a higher average total bill, or if the person is a non-smoker, then he is having a higher average total bill. That we want to find out. Okay, so what is the thing we are grouping? We are grouping the smoker column. So df dot group by, we will be grouping this smoker column based on this total bill, based on the total bill, and we want to find out that do the smokers or non-smokers have a higher average total bill. So we will be doing mean. So it will be giving the answer for yes and no. For yes, what is the higher average total bill, and for no, what is the higher average total bill? Let's see. Obviously, for the smokers who does a smoking, for them it is having a higher average total bill. Fine. So from this we can also get it that the person who is smoking, they are giving more profit to the specific business. Like in the, at least in the restaurant market, they are giving more profit, right? Now how can I do it? Like how can I do the visualization for it? We will be doing, as because we are having only two values for the smokers, only yes or no, we can do it using the box plot or bar plot, as because it one column is numerical, another column is categorical. So we will be doing sns dot box plot. Here I will be passing data is equals to df. In the x column I will be passing smoker, and in the y column I will be passing another column was total bill, right? Yeah, total bill. Let's see, it is giving an accurate, very good graph, very clean and very good representation it is giving. Now let's see one thing, let's move on to the next question, that do smokers or non-smokers give a higher average tip? Do smokers or non-smokers give a higher average tip? Obviously the smokers will be the one, I know. Let's see. Still, do smokers or non-smokers give a higher average total, higher average tip, higher average tip? So same thing, we will be grouping smoker, we will be grouping based on the tip. Df dot group by, we will be grouping smoker, we will be grouping smoker based on tip dot mean. Let's see, obviously the smoker is giving a higher average tip, less than the non-smoker. Now let's move on to the next question, that is, on which day is that average total bill is highest? on which day the average total bill is the highest. Okay, so for this, what I want to find that for each day, like Sunday, Monday, for each day, what is the higher average total bill? Like for if in Sunday we are having a higher average total bill, or in Monday we are having a higher average total bill, that we want to find out, that we want to figure it out. Okay, so we will be doing df dot group by, and we will be grouping the day column. So if you look carefully, again we are doing the numerical categorical analysis. Again we are doing the same thing, numerical categorical analysis. Here we will be passing total bill dot mean. See, we are getting a higher bill on Sunday. Obviously, we will be getting the highest revenue on Sunday itself, right? That is very obvious. And as because it is a numerical categorical analysis, you can go on for the bar plot or box plot. That will be better. That will be better. Whenever you will be going for checking the distribution, what type of distribution, whether it is normal or the data is skewed on the either ends, then you will be going for the dist plot. Okay. Now let us move on for categorical analysis. Categorical analysis. Like both the columns will be categorical. Categorical versus categorical. Categorical. I'm writing the wrong spelling. Categorical. Okay. So what is the relationship between the gender and smoker status? What is the relationship between the gender and smoker status? Let me write down the question. What is the relationship between the gender and smoker status? Okay, so for that we will be using, as because it is one of the categorical analysis, so what we will be using, we will be using one method known as cross tab. We will be using one method known as cross tab, where we have to, when we want to find the relationship between two categorical data, then we will be using the method of cross tab. Pd dot cross tab, and here we will be passing df sex and smoker, right? Df smoker. See, so cross tab is basically giving you in a tabular format, in a cross tabular format. Okay, it is giving you the entire data. First of all, it is smoker, yes or no, and sex, male or female. For smoker, yes, male smokers. How many there are male smokers are present? 60 male smokers are present. How many male non-smokers are present? 97 male non-smokers are present. So you can get the entire data overview in a single tabular format. For that, you will be using this method known as cross tab. Now, as because it is a categorical data, how can you visualize the entire thing? So you will be using one graph known as the heat mapping. SNS dot heat map, and here you will be passing one argument known as table, annotation is equals to true, and here you will be passing the format will be, format we can pass as D. Now how I can write all these things, if you just go on to the Seaborn documentation, you can find all the arguments of the heat map, all the features of the heat map you can find over there, and you can just browse from that. Okay, there is nothing to learn from this. This is just the styling we are doing. And the C map we will be doing is blues. Under blues we will be doing blues. Table is not defined. Okay, sorry, table name we will be saying, right? So the table name is df. Okay, sorry, we have not passed the table. Okay, got it. So we have to pass it, we have to store it in a table. Okay, we have to store it in a table, in one variable named as table. You can name anything, you can name anything of your wish. So here I will be passing the table name, that is the table. Now it will work, see, now it will work. So from this heat map you are getting the exact idea based on the color shades, based on the gradient of the colors. Now if you look carefully that for smokers, male smokers, how many there are numbers are present? 60. So 60 is marked with sky blue. Then how many female smokers are present? 33. As because it is very less, the color is also very dull. Color is also very dull. How many male non-smokers are present? 97. As because the number is very high, that is why it is marked with navy blue, like dark blue, right? So in this way it is working. Got it? Now this is all about the categorical data. Now, and this is all about, then this is the end of bivariate analysis. This is the end of bivariate analysis. Like how we have done for the bivariate analysis, we will be doing the same things with the multivariate analysis as well. If you have understand the bivariate analysis well, in a very well mannered, then you can understand the multivariate analysis also. Multivariate analysis is also working in the same way like the bivariate analysis. Fine. So here what we will be doing, let us start with multivariate analysis. Multivariate analysis. Analysis. So in multivariate analysis, I am giving you one question. Just analyze the total bill, tip, gender, and smoker status together. I want to analyze. I want to analyze total bill. Total bill. I want to analyze total bill, tip, gender, and smoker status together. Smoker status together. Okay. For that, what I will be writing, I will be obviously I have to do a group by thing. So here from this question you have to understand a very important thing, that is, what are the categorical data we are having. What are the categorical data we are having? Now one very important thing, we will be grouping down here when we will be doing the multivariate analysis. Here when we will be doing the multivariate analysis, majority of the time, not all the time, majority of the time we will be grouping the categorical data. Majority of the time we will be grouping the categorical data. Okay, so df dot group by. Now what are the categorical data present over here? The categorical data present over here is sex, uh, gender, and smoker. Yeah, gender and smoker, these are the categorical data we are having. First of all, I will be writing sex and then the gender, sorry, smoker. Yes, smoker. Done. Now this, on these two columns, sex and smoker, we will be grouping the average, not average, we will be grouping the total bill and the tip. We will be grouping the total bill and the tip, right? Now here we will be passing um, total bill, total bill and total, wait, total bill and tip. Okay. Now one very important thing, that is GroupBy doesn't work with non-aggregate data. So what are the aggregation we can do? We can find out the mean. Check it down. For male smokers, what is the average total bill and what is the average tip? For male non-smokers, what is the average total bill and what is the tip? For female smokers, what is the average total bill and what is the tip? And for female non-smokers, what is the average total bill and what is the tip? That we are finding out from this example. I hope it is clear. Now suppose I want to find out, I want to do the visualization for it as well. How can we visualize? SNS.scatterplot. Yes, everything is written. I have given the data is DF, X as total bill, Y is tip. Here, important thing is, as because we cannot increase the dimension, right? We cannot increase the dimension because we are using a two-dimensional matrix. We are using a graph which is having only two axes, X and Y. We cannot increase it. But how can I then make a multivariate analysis? How can I visualize the multivariate analysis? For scatter plot, we are having two arguments, two features, that is hue and style. So hue is basically based on the total bill and tip, like based on the sex and smoker, how the total bill and tip is changing. Based on the smoker and tip, how the based on the sex and smoke based on the sex and smoker, how the total bill and tip is changing. See how I am only getting confused. Based on the sex and smoker, how the total bill and tip is changing. Now what is the meaning of hue and style? Hue and style will be giving you different color variations in your data. Let me show you that. See, male is represented by blue dot and the female is represented by the orange dot. Smokers are represented by dots and non-smokers are represented by cross. Now from this entire graph you can figure it out that whether they are paying the higher total bill or the lower total bill, along with the representation and the analysis of the tips. Okay, now this is a very good way of representing the multivariate analysis when you are having more than two columns, when you are analyzing with more than two columns. And I would recommend that if you are doing the multivariate analysis, you should go for the scatter plot only. That is a very good way of representation. You can use another way, that is the rail plot, relation plot. Okay, relation plot, rail plot. Rail plot will also give the same thing, same as scatter plot, but with a different styling effect. That's it. But with a different styling effect. That's it. Okay. Now this is all about univariate analysis, bivariate analysis, and multivariate analysis. So now we will be starting with joins at first. So first we have to understand that why we will be going for joins, why we are going for joins, and what is join, and why we are going for join. This thing you have to understand. See, suppose I am considering one company, like food delivery company. I am just assuming. I'm assuming Zomato. Okay, Zomato. Now you guys just say one thing, that Zomato is a very big company who is managing many chains of restaurants, right? They are managing chains of restaurants, right? They are also managing delivery partners, delivery partners. They are managing customers. They are managing orders, right? So how many things they are managing? You guys just say, and maybe even more they are managing. Now the factor is that there will be many restaurants, there will be many partners, there will be many customers, and there will be many orders. You guys just answer one thing, that are they managing everything from a single database or from a single data set? Are they managing everything, like the data of the restaurant, data of the delivery partner, data of the customers, data of each and every orders? Are they managing from each and every, like each data set or each database? Obviously no. They are maintaining separate individual databases or data sets, like a separate data set for restaurant, a separate data set for restaurant, a separate data set for the delivery partners, a separate data set for the customers, a separate data set for the orders. For each and everything, they are maintaining a separate data set which will be having multiple features or multiple columns. Now I am taking three columns or three data set, not three columns. I am taking three data set, like customer, restaurant, and orders. And based on the data set, you guys just try to answer few questions based on what you have learned from the previous video, right? Okay, so I have taken this data set. Now in this three data set, you can find one table for customer, sorry, one table for customer, one table for restaurant, and one table for order. Now just go through the data set once. First, in the customer data set, we are having customer ID, customer name, and the customer city. In the restaurant column, in the restaurant table, we are having restaurant ID, restaurant name, restaurant city, and the cuisine. In the orders table, we are having order ID, customer ID, restaurant ID, order amount, and the order status. Now, if you look carefully, that in the previous class we have learned about group by, right? Now, from just one data set, if I just ask you one question, that is, just say one thing, that which restaurant have done how much order each day, or like all total, each restaurants have done how much order all total, like the total amount I want to get. Can we get it? We can't get it. The reason is because if we see for the restaurant name, so that's the reason that we can't actually find what is the total order amount done by each restaurants. The reason is because the reason is, see, in the restaurant column, if I see, in the restaurant column, if I see, we don't have the total order amount. We don't have the total order amount, right? And in the order column, we are having the order amount, but we are not having the restaurant name. Instead of that, we are having the restaurant ID. And that is why we have to come up with the joins. We cannot say like how many customers have successfully got the orders or received the orders, or what is the total order amount by each customers. We cannot say that, because the customer name is present in the customer table and the order amount is present in the order table. Now these are the two different tables we have to work with, and that is why we have to come up with the joins. Okay, so now you guys just answer one thing, that I just want to know that which restaurant have done how much order, like what is the total order amount for each restaurant. I am writing down the question. You guys just try to answer this question. What is the total order amount? What is the total order or order amount done by each restaurant? Done by each restaurant. Can you say that? Like, I want the restaurant name over here. Okay. Can you say that? You can't say that. The reason is because if you look carefully, if you go for this restaurant table, you can find the restaurant name over here, but you cannot find what is the order amount done by each restaurant. What will be the order amount done by each restaurant? Like, there is no order column. Like, order column is not present in the restaurant table, right? Where the order column is present? Order column is present, or order amount column is present in the order table. And in the order table, we don't have the restaurant name. We don't have the restaurant name because this particular company is maintaining everything in a separate table. Like in the customer table, we have customer ID, customer name, or customer city. Restaurant is having restaurant ID, restaurant name, city, and cuisine. Orders is maintaining the IDs and order amount and order status. Now, if I say another question, if I ask another question, like what is the total order amount done by each customer? What is the total order amount done by each customer? Can you say that? You can't say that again. The reason is same. The reason is, in the customer table, you don't have the order amount, and in the order table, you don't have the customer name. And this is where we are coming across with the concept of joins, and this is where we need joins. We have to join the tables so that we can answer few of the questions. In the previous video, we have learnt about group by. by grouping the specific column we can answer certain questions, but this type of questions we can't really answer without doing the joins, because a company or an organization is maintaining its database in different tables, because they are of separate domains. Like one table they are maintaining of specific customer, one table they are maintaining of restaurant, another table they are maintaining of orders, right? And this is what we are maintaining different tables. I hope this is clear. Now, before directly going on to the joins, we have to understand two points, that is about the unique id, about the uniqueness of each row, about the uniqueness of each row, unique id, unique id. So if you look carefully that in the customer table we are having customer id, in the restaurant table we are having restaurant id, in the order table for each and every order we are having unique order ids, right? Now these things are technically known as primary key, they are known as primary key. Now if you have completed SQL, then you must have gone through this term primary key, but if you have not, I am explaining it. Primary key is just a unique key or unique identification code for each and every row, by which you can identify one specific row, one specific data you can identify, and that is what primary key is. Another term is foreign key. Another term is foreign key. Now what is foreign key? A foreign key is a column in another table. A foreign key is a column in another table, and it is useful for creating the relationship. It is useful for creating the relationship to maintain the referential integrity. Now what I have said just now, let me write it down. Let me write it down. Wait. Primary key is useful for unique identification of each and every row. Unique identification of each row. Fine. That is easy to understand. But foreign key is not that much easy to understand, but I am making it easy. Foreign key is just a key in another table. It is present in another table for referential integrity. Referential integrity. Now, what is the referential integrity? See it. In customer table, we are having this customer ID. In the order table, we are having this same customer ID. Now to join these two table, this customer table and this order table, we need this customer ID because they are the common one. This customer ID will be behaving as the foreign key. If you look carefully in the restaurant table, we are having the restaurant ID, and in the order table, we are having this restaurant ID. Now with these two columns present in this two data set, we can actually join, or we can actually merge two columns, two tables. Now they are useful for the integrity of the two tables, and this is ensuring that the data remain consistent. Now how the data will be remaining consistent, that we will be seeing in the like upcoming parts of this video. Okay, now the two concepts are clear. One is primary key, another one is foreign key. Foreign key is approximately 50% it is clear, 50% it is not. I can understand that. And primary key it is clear. There is another concept you have to understand, that is relationship. That is relationship. Relationship concept you have to understand. Now what is the relationship? Relationship, I am explaining it in a simple and easy way. That is, if you look at this columns, customer, restaurant and the order table, customer, restaurant and the order table, you can feel one thing, that one customer can give multiple orders. I am writing it down. One customer can give multiple orders, right? And one restaurant can receive multiple orders or can give multiple orders, right? One customer, multiple order, one restaurant can receive and can get multiple orders. Now this is the relationship between the two tables. This is the relationship, one to many, many to one. Like customer, they can give multiple order. So one to many. One restaurant can give multiple orders, can receive multiple orders. If they are receiving multiple orders, so it is many to one, many from one, or one to many. Now don't go to such concepts. These are confusing. This will be confusing for you. Don't go to, sorry, the arrow mark is in a wrong direction. I have given, yeah, now it's correct. Don't go for such concepts. Try to understand by your general knowledge with the help of this data set. Refer to the data set directly. Don't go for one to many, many to one. These concepts will be confusing sometimes, because when you will be handling multiple table at a time, you can't really feel by your sixth sense that which will be one to many or which will be many to one. That will be really difficult to understand when you will be working for the real life scenarios. And that is why I am saying, try to analyze each and every table individually by your general knowledge. Don't use any relationship concept. Just try to understand that if I look for customer, they can give multiple orders to multiple restaurants. If I say it in general way, one customer can give multiple orders to multiple restaurant at a time. One restaurant can get multiple orders from different customers, right? So can you understand the relationship? Now this is how you have to go for the relationship. You should not go for one to many or many to one or one to one like that. That will be difficult for you to understand. I hope this concept is clear. Now let us directly move on for the joins. What is join? So join, if I say, join is basically a concept which is combining two tables, two or more table at a time by using a common column. Let me write it down. What is join? What is join? Join is basically combining, two columns, two or more columns, you can say, not column, sorry, table. Combining two tables using a common column, By using a common column, it is combining two or more tables at a time. Now that is what join is. Now if you look carefully, the examples or the tables I have written, if you want to join customer along with order, what is the common column we are having? Customer ID and the customer ID. Customer ID is present in both the order table and the customer table. Now based on these two column, we can join these two table. With the help of this customer ID column, we can join these two table, customer and this order. Okay. If you say restaurant, in restaurant, what is the common column we are having? The common column is restaurant ID. In order, what is the column we are having? Restaurant ID. The common column is restaurant ID. So with the help of restaurant ID, we can join these two table, orders and restaurant. And in this way, these three tables are getting interconnected. In this way, the three tables are getting interconnected. Okay, so I hope the things are getting clear, that join is just a thing by which we will be joining the tables with the help of the common columns. Now, first of all, when we will be getting the data set, when we will be getting three data set, what all things we have to do? We have to go for how many tables are there, what we have gone for the first video of the data analysis. In the first video we have seen, like after we get the data set, we have to go for the shape of it, like how many rows are there, how many columns are there. We have to go for the physical intuition of the data set. Then we have to move on forward. Then we have to move on for what is the null values present over there, how many null values are present over there, right? These all things we have to see. And after that we will be going for the statistical analysis. After that, when we will find in the real time scenario, when we will find that we are actually dealing with multiple tables at a time, we will be going for this joins concept, and we will try to answer some of the questions which is necessary for the market analysis. Okay, so now once after we get the data, once after we get the different tables, what we will be doing, we will be identifying the primary key. So what will be the primary key for the customer table? The primary key will be CID, or the customer ID. Why it will be? Because what I have said for the primary key is just a key which is useful for unique identification of one specific row. What will be the primary key for the restaurant table? It will be obviously restaurant ID. What will be the unique identification for or the primary key for order table? It will be order ID, right? Now, after we find out the primary key, we can actually get it that what will be the foreign key, which key we can use for the referential integrity with the another table, like for merging another table, right? So let us see all these things directly over Colab. That will be easy to understand for you guys. I will be importing these three tables, exact three tables in Colab, and then we will be performing, or we will be trying to understand this joins concept over there. Okay, so before we move on to the Colab, let us understand that the types of joins. Okay, before going to the practical part, we have to understand few things. First of all, we have to understand that is the type of joins. Type of joins. Type of joins. So in type of joins, we have primarily four categories are there. Primarily, we have four categories. First is inner join. Inner join. Second one is left join. Third one is right join. And the fourth one is the outer join or full join. Okay. Now the factor is that we don't have only these four categories of joins. We have more two categories, that is self join and cross join. Now those joins we don't use much. We normally use these four categories: inner join, left join, right join, and outer join. Okay, so first of all, we have to understand, or we have to go through the inner join. Inner join. So for understanding inner join, I am considering two columns. Okay, I am considering two columns. First one is the customer column, customer table, not two columns, actually two tables, customer tables. So in customer tables, we will be having, like we have seen, customer ID will be there, customer name will be there, and customer location will be there. Okay, so customer ID I'm considering C01, C02, C03, Rahul, Meera, and Sugam. Okay, customer location is Bangalore, Hyderabad, and Kolkata. Another table I am considering, that is orders table. Orders table. So in orders table, we will be having some column like order ID. Okay, then customer ID will be there, based on which the joining operation will be performed. As I have told, what is the definition of join? Join is basically the way by which we will be combining or we will be joining two tables based on one common column. So we have to define some common column by which we will be joining two tables. So customer ID will be there, then order amount will be there. Okay, so I'm considering these three columns only. Order ID is O1, O2, O3. Okay, customer ID is C01, C01, C02. Maybe the last customer, that is C03, have not ordered. Fine. So order amount I'm considering as 200, 205 and 400. Okay, now this is the two table, customer and the order. Now what is inner join? Inner join means it will be returning only those matching records from both the tables. What it will be returning? It will be returning only matching records. It will be returning only matching records from both the table. From both the table. So in this two table, customer and order, we will be combining those two table, or we will be joining this two table based on this customer ID which is present in both the table. Now if you look carefully, inner join will be returning only those records which are common in both the table. That is, if you look carefully, C01 is present in customer and order both. It is present twice. C02, is it present in the order table which is present in the customer table? Is it present in the order table? No, it is not present. Then coming to C03, is it present? Oh sorry, C03 is present, C02 is present, but C03 is not present, right? C03 is not present, but C02 it is present, yes, right? So it will be giving us, it will be returning us the record for C01 and C02, as because they are the common records for both the tables. Now if I want to represent this inner join with the help of the Venn diagram in the set theory, suppose these are the two tables A and B. It will be returning only those records which are matched in both the tables. That is this part, that is A intersection B. Inner join is representing A intersection B. Now how to perform the inner join? For performing the joining operation, we will be using one method known as pd.merge. Okay, so pd is basically the alias of pandas and merge is the method. So pd dot merge, inside it we will be passing the table 1 name, table 1, name of the table 1, then table 2, then table 2, comma, on what common table, on what common column. So here we will be giving the name of the common column. That is, for this case we will be using this customer ID which is present in either tables, customer ID. And what type of joining operation we are performing? That is inner join. So here we will be mentioning either inner or outer or left or right. Okay, so this is how we will be performing the joining operation. Now how to go for this inner join operation? We will be writing here, in place of the table 1 we will be writing here the customers. In place of table 2 we will be writing the orders, and here we will be mentioning the inner. Fine. So I hope it is clear for you that how the inner join is working. Inner join will be returning, or it will be giving us the return only the matching records from both the table. This is how the inner join will work. Fine. Now let us move on to the left join. Let us move on to the, first of all let us move on to the outer join. That will be easier. Outer join. So as per Venn diagram, outer join is the union part, A union B. That is, it will be returning records for both the table, like all the rows it will be returning. Okay, like outer join keeps everything from both the tables. Keep every records, keep every records from both the tables. Okay, keep every records from both the tables. Fine. Now if I do use this two tables, customer and order, so I will be using this customer in table 1, orders in table 2, and in place of the how I will be just writing this outer. So it will be returning all the orders, or like records from both the both the tables. It will be returning records from both the tables. Fine. This is how the outer join will be working. Now the left join and right join. Uh, this is also easy one. This is also easy, but as compared to inner join and outer join, it is bit tricky to understand. First of all, left join and right join, they are just the vice versa. They are just working opposite to each other. Okay, sorry, left join. So in left join, what happens? It will be keeping every row from the left table. What the left join will be doing? It will be keeping every row from the left table, from the left table. So what is the left table? That's the point. Now I have taken this example, that is customer id, sorry, customer and orders, right? So in case of the left join, what we will be doing, pd dot merge, here we will be giving the table 1 and the table 2 name, right? Now the left table means what? Left table means the table name which we are writing at first. The table name which we are writing at first. So suppose I am writing orders and here we are writing customers. Okay. So orders is becoming the left table and it is becoming the important table. This orders table is becoming the important table, because it will be returning all the row from the left table. So orders is becoming the important table. So remember this point, when you will be going for the left join, the table name which you are maintaining or mentioning at first, that table will be the important table for you, and for that table it will be returning all the records. Fine. And right join is exactly opposite to the left join. Fine. It is exactly opposite to the left join. Now let us move on to Colab and watch these things, because practically things will get more clear for you guys, right? Okay, so now what I have done over here, the example which I have given at the beginning, that we will be having customer table, order table and the restaurant table. I have taken exactly same data what I have taken in the beginning. Same example I have taken, same records, same example I have taken over here. So I have created this data frame by data frame manually. Now you guys will be asking, sir, why you are creating this data frame manually? You can just use any downloadable data set. uh, See, for explaining this thing, I couldn't find any such example which is good for understanding. So I have created my own data frame so that it will be good for understanding for you guys. And after that, when we will be going for projects, we will be taking some real life data set. We can download it from Kaggle, or you can get the data set from by doing the web scraping. Fine. But as of now, for the understanding concepts, for understanding entire parts of the joining, like indicators, sorting, query methods, everything, you need to go through this data set. That will be better. That will be better, I guess. Okay. So first of all, let us move on to the inner join. Let us do practically inner join. Okay. So let me take one question. Let me consider one question. Okay, wait. Yeah. So one question we can find is, all the customers who have placed orders, who have placed orders. Okay, so if you look at this question carefully, we are dealing with two parts. So all the customers who have placed orders, now how can we get that which customers have placed orders? Now in the customer table we are having 5 customers: Asa, Rahul, Meera, Kabir and Nisa. Now it's not like that all of them have placed orders. They all are customers but they have not placed order. It may happen, right? Like suppose I am taking the example of Zomato or Swiggy. They might have downloaded the application but they have not placed any order, but all of them are the customers, right? Those who have downloaded the application, those who have registered for that specific application, they all are the specific customers for the specific app or the specific company, right? So they can be all customers, but it's not like they have all placed the orders. So I need all the customers who have placed orders. So if we want the customers who have placed orders, then we need something. If we break this question, we need something that is present in both the table, that is order and customer. So we need the customer ID which is present in the customer table as well as the order table. Obviously the customers whose order is being placed, maybe it is completed or cancelled, whatever it is, the customer who have placed the order, their customer ID will be there present in the order table. So that is what we want. So we want all the customers who have placed the orders. Now we can make the solution of this by joining the order table along with the customer table, and we will be finding all the customer ID which are common in both the tables, that is customer and the orders. That is the thing we want, right? So this is a perfect example for the inner join. So we will be doing pd.merge, and here we will be joining two columns, that is customers and orders, right? Two tables we are merging, not columns. Customers and orders, and based on what column we are merging, that is customer ID. So on we will be writing customer ID. Fine. And what is the type of join we are doing? The type of join we are doing is inner join. Fine. Now let's run this. See, we are getting all the customers who have placed the orders or who have done the ordering. So C 1, 2, 3 and 4. Customer 5 have not placed the order. That is Nisa. Nisa have not placed the order. Maybe she is the customer of Swiggy or Zomato, but she have not placed the order. She have registered for the specific application, but she have not placed the order. Now, how this can be beneficial for the company? See, customer can get to know that okay, this girl Nisa have downloaded this specific application, but she is not using this. So what the company can do, companies can give uh, personalized notifications or personalized marketing to Nisa, like you have seen for Zomato, right? You have seen for Swiggy, like how they are actually marketing their products, how they are marketing their restaurants, right? So like that they can market, they can create personalized ad for the specific members who have registered for the specific application but who are not using that application, right? Got it? I guess it is clear. Now let us move on to the second question. Let us move on for the left join. Let me figure out the question. Mm, Customers is there, restaurant ID is there, orders is there. Fine. Left join. So in left join, we can figure out. So all the customers, including the customers who have not ordered, who have not ordered. So what we want? We want all the customers from customer table. We want all the customers from the customer table who have ordered, like who have placed the orders, but along with the customers who have not placed the orders. Like we want the record for all the like we want the record from for each and every rows of the customer table. That is what we want. So here, as because we are doing the left join, let's see what it is returning. So what we will be doing, pd.merge. Now see, we want the record for all the customers, right? So we need the customer name. we need customer name. So which column is important, which table is important? Obviously the customer table is important. We need the record of all the customers who have placed the orders and who have not placed the orders. So order is not the important one. Which one is important? Customers. Customers is the important one. So we will be keeping customer table at first or at the left side, customers, and then we will be keeping orders. Fine. On basis of what we will be joining? Customer ID. Customer ID, right? And what type of joining operation we are doing? Left join. Now let's see. See, we are getting all the records from table 1, that is the customer table, but Nisa have not placed the order, right? We have seen that Nisa have not placed the order. Asa, Rahul, Mira and Kabir, all 4 have placed the order, but Nisa have not placed the order. So for that, as because Nisa have not placed the order, so obviously her customer ID will not be there in the order table. So as because her customer ID is not present in the order table, that's why it is giving as NaN, or it is giving null value, because Nisa have not ordered. Obviously, as because Nisa have not ordered, there will be no ordered ID for her, there will be no restaurant ID for her, there will be no order amount for her, right? So like this we can get, or we can do the left join. So left join means, in the left join, the table which is important, we will keep that table at first, that is at the left side, and the table which is less important, we will be keeping it at the right side. And the same thing will also work for the right join. It is just the vice versa of the left join. Let's see, when we will be doing the right join, what it will be returning. Right join. Fine. So pd dot merge, same thing we will be writing. Here we will be writing orders at first, as because order is not so much important, customer is the important one. Customers, we will be keeping it on the right hand side, on customer ID. Customer ID, how we will be merging? That is a right join. Now let's run it. See, same thing it is returning, but the order is different. That's it. Same thing it is returning like the left join, only the point is it is giving us different order. That's it. Fine. Now how to do the outer join? PD okay, let me figure out one question for outer join. So all the customers, and all orders, including unmatched records, including unmatched records. This is the question we can solve with the outer join, that is A union B. It will be returning all the records. Outer join keeps everything from both the tables. Every records it will be returning from both the tables, right? So for that, what we will be doing, pd.merge, same thing we will be doing, pd.merge. And here there is no concept of that this table will be coming at first or that table will be coming at second. There is no concept of like that, because we are doing A union B simply. So customers, comma, orders on customer ID, and what type of joining operation we are doing? We are doing outer join. That's it. See, it is returning record for both the tables. It is keeping everything from both the tables, right? And this is how the outer join will be working. Now I guess these 4 types of joining operation is clear for you guys. Now let us brush up these skills by solving more typical questions, and we have to also go for joining operation along with group by. In the previous video we have learned group by, right? So this video, what we will be doing, we will be joining 2 or more tables, and we will be performing the group by operation on that, to make the things more complex, because real life scenario and real life analyses are much more typical. They are much more complex. Fine. Okay. uh, the question I am giving is, suppose what is the total order amount, what is the, sorry, total order amount made by each restaurant. What is the total order amount made by each restaurant? What does it mean by? See, this question I have already given. This question I have already given while I was starting with the joining session, right? Now, let us break this question. Let us break this question. Otherwise, you cannot understand that. See, what is the total order amount? Total order amount made by each restaurant. Now, here what do we want to find? Here we want to find the total order amount made by each restaurant, and here the restaurant means the restaurant name. Restaurant name. Okay. Now, if I move on to this Colab, if you look carefully about these tables, you can find it that where we can find the restaurant name, we cannot find the order amount in the same table, right? Now, where we can find the order amount, we cannot find the restaurant name over there. So obviously we have to merge these two tables, that is restaurant and orders, based on the restaurant ID, because restaurant ID is the common one, common column between them, right? That is clear. So what we have to do? We have to do joining operation. We have to merge the two columns, that is orders and restaurant. So here we are getting two columns, that is orders we have to merge, and restaurants we have to merge. Now, which one is important and which one is not? See, if you break this question, you can find it that what we want. Suppose the restaurant name, there are four restaurants, I am taking A, B, C, D, just assuming. I can't remember the restaurant name, I don't remember it. Something Bengal bistro is there, green ball is there, whatever. So I want the total amount made by each of the restaurant. So for restaurant A, it will be somewhat around 700. For restaurant B, it will be somewhat around 1200. For restaurant C, it will be somewhat around 800, like that. I want to find what is the total order amount. I want to find what is the total order amount made by each of the restaurants. I want the restaurant name, right? Now here, if you look carefully, what is the important thing? What is the important column? The important column is this order. The important column is this order, right? Order amount. Important column is this order amount. Now this order amount is in which table? That is in the order table. So obviously we will be keeping the orders at first, and then what will be the next table? The next table will be restaurants. Fine. After that, what we will be doing? We will be merging these two on, and how we will be doing is left join. We will be doing. Now the factor is, see, if you look carefully, we are actually grouping these restaurants, right? We are actually grouping these restaurants based on the order amount. We are actually grouping the restaurants based on the order amounts. So let's write the algorithm. What we are doing? First of all, we are joining two tables. Joining two tables based on one common column. Then what we are doing? Then we are grouping restaurant name. Then we are grouping a restaurant name based on the order amount. Okay, as because we want to find the total order amount. Now this part, as because we want to find the total order amount, total. Okay, so as because we are grouping, and after grouping we want the total order amount, what we will be doing, we will be summing. And the group by operation is what? Group by operation is an aggregate function. So without the aggregate function, group by operation or group by function will not work. Now let's move on to Colab. Let's move on to Colab. See it over here. PD dot merge. What are the columns we are merging? Orders will be in the left hand side, orders and restaurants. Fine. Now on what column we are merging? On the basis of the restaurant ID. On the basis of the restaurant ID, we are merging both the columns. Now what is the way we are merging? That is the left join we are using. Fine, very fine. Okay. Okay, sorry, I have missed the quotation. Left. Yeah. Now we will be doing the group by, we will be performing the group by operation over here. So what is the thing we are grouping by? We are grouping the restaurant names based on that order amount. We are grouping the restaurant name based on the order amount. So a restaurant name will be grouped based on the order amount. Fine. Now the second operation is done. Now we want the total order amount, and group by operation also is an aggregate function. It can't work uh, without the aggregate function. So aggregate function we will be using is sum, because we want the total order amount. So sum. Now let's run it. See, now we are getting that Bengal Bistro have the least order amount, Spice Route have the second order amount, and the Urban Tarka is having the most order amount. Now we want to sort it. I just want the restaurant, I just want the restaurant which is having the most order amount. I just want the restaurant which is having the most order amount. Or I can do one thing, I can modulate my question. Which restaurant generated highest revenue, the highest revenue? Which restaurant generated the highest revenue? Okay, so for that we can do what? Same thing, same query we will be writing, but one thing I will be writing extra, that is sort values. VALUES, yeah. So here we will be doing ascending, ACNDING, ascending is equals to false. Why ascending is equals to false? Because by default sort value will be returning the records in ascending order, and when I am putting it ascending is equals to false, it will be returning in descending order. That means it will be returning the restaurant which have the highest revenue at first, and like that it will be moving downward side. Now let's run it. You can say that Urban Tarka is coming at first because it is having the highest revenue. Very good. Easy to understand, I guess. Now we can move on to the next question. The next question we can find is uh, wait, what is the total order amount made by each customer, right? What is the total order amount? What is the total, wait, total total order amount made by each customers? Along with that, I am adding this question. I want the customers with highest uh, total order amount. Total order amount. Now this will also work like that, also like the previous question. Now this question will also work like the previous question. Same thing we will be doing. PD dot merge. Here we will be keeping orders at first, as because money is important, order amount is important. Then we will be keeping customers. Based on what we will be joining? We will be joining is customer ID. We will be joining based on the customer ID. Fine. Now, what is the type of join we are doing? We are doing the left join. We are performing left join. Very good. Now, what are the things we will be grouping? That is the customer name. We will be grouping based on the customer name. Group by customer name. Based on what we will be grouping? Based on the order amount. Based on the order amount. And we want the total, as because we want the total, we will be giving the aggregate function as sum, and I want the customer with highest total order amount. So that's why again sort values, and ascending will be false. That's it, done. Now let's run it. See, you can find it that Rahul have ordered the most. Kabir, Mira, followed by Kabir, Mira and Asa. Fine. Then the next question we will be solving is, so the restaurants so the restaurants uh, along with their number of orders. So what we want to find? We want to find the restaurant name along with the restaurant, like a restaurant name will be there along with how many orders each restaurants received. Received. Now let's go on for finding the intuition behind this question. Where is the restaurant table? Here. Yeah. So we want to find that Spice Route, Urban Tadka, Bengal Bistro and Green Bowl, how many orders each restaurants have received. So here we want to count how many restaurant ID is present in the order table as per the numbers. So restaurant ID we will be counting in the order table. What we will be counting? We will be counting the restaurant ID present in the order table. Very good. Now let's do this operation. So same thing, pd dot merge, and here we will be merging the two columns, that is orders and restaurants. Fine. And on the basis of what we will be joining? Restaurant ID we will be joining. Now how we will be joining? Based on, like, we will be performing the left join. Done. Now you will be grouping by the restaurant name based on the uh, restaurant ID. Based on the restaurant ID you will be grouping. Restaurant name, you will be grouping RESTAURANT. Yeah, order ID is not restaurant ID. You will be actually checking the order ID. Dot count. See it. Bengal Bistro have received 2 orders, Spice Road have received 2 orders, and Urban Tarka have also received 2 orders. Now the one restaurant, from one restaurant people have not ordered that. Now which was that restaurant is Green Bowl. From Green Bowl people have not ordered, so it is offering something healthy cuisine. Now people don't want healthy foods at all nowadays, so that is why people have not ordered. That's a separate thing. Fine. So we can got it that from Green Ball people have not ordered. Very good. Now move to the next question. Next question will be a bit tricky one. Which customer ordered from which restaurant? Which customer ordered from which restaurant? Okay, which customer ordered from which restaurant? Now there are 2 columns we have mentioned, customer name and the restaurant name. Now can we join the customer table and the restaurant table? Is there any common column between them? Customer ID, customer name, customer city, restaurant ID, restaurant name, restaurant city, cuisine. So there is no common column between these two tables, customers and restaurant. So for that, what we have to do, we have to join customers with orders and then orders with restaurant. So we have to merge all the three column, all the three tables. We have to merge all the three tables. Now that is very tricky. Now let me write it. What we will be doing, we want which customers ordered from which restaurant. First of all, we will be merging, remember this thing, we will be merging orders with restaurant or customers, and then the remaining will be merged with the other table. So I am writing orders dot merge. So that means order table will be merged with the next table. So I am taking as orders is merged with customers. Okay, orders is merged with customers. On basis of what we will be merging, because order table and the customer table have one common column, that is the customer ID. So we will be merging based on the customer ID. Customer ID. Very good. Customer ID. ID. Yeah. Done. Very good. Then the remaining, like the entire thing, like merged table will be again merged with the restaurant table. Now again merge operation we will be performing. So this is the concept of method chaining, where we will be merging or where we will be using multiple methods in a single line separated by the dot operation. It's not like always all the methods will be of same type. They can be of multiple type, like in the group by operation in the previous questions you have seen that merge is used, merge method is being used with the group by is being used with sum is being used with sort values, like that. All these operations is the method chaining, is an example of method chaining. Here we are using merge method for two times in one single line, as because we are merging more than two columns, two tables. We are merging more than two tables. So merge merge restaurants. On what we will be merging? On restaurant ID. On restaurant ID. Very good. Yeah. So which customers ordered from which restaurant? Now let's run it. Let's see it. Class str was passed. Let's check what's the error I have done. Okay, so can only merge series or data frames. Okay, fine. The mistake I have done is I have put a quotation over here. That's why it is not running. Fine. Now it will run. Yeah. So you can find which restaurant, or like which customer have ordered from which restaurant. See, Asa have ordered from Spice Route, Rahul have ordered from Urban Tadka, like that. It is giving record for each and every customers, like from where they have ordered. Fine. I guess this question is clear for you guys, how to do like how to join more than two tables. I hope this concept is clear for you. Now guys, I will be giving you few homework, like you should do you should do it, because like whatever the questions I have solved still now, based on that only I will be giving you some homework. Like if you face any doubt, any problem, you can ask me, you can directly contact me, and if you have any doubt you can write in the comment section. If you can solve it or if you can't solve it, everyone please write in the comment section that whether you are doing it or not. Okay guys, so now what I am doing, I will be giving you homework. Three questions I am giving. If you can solve it, please mention it in the comment section, and if you can't solve it, you can ask your doubt directly to me. uh, the contact details are given in the description box. You can directly contact me or you can write in the comment box as well, whatever. Fine. So let me write the questions. I will be giving you the questions based on the questions I have solved recently. So how many orders Did each customer's place? Did each customer placed? I hope these questions you can easily solve it. Then what is the average order? What is the average order amount of each restaurant? Then which cuisine earned the most? Sorry, which cuisine earned the most? How many orders? How many orders did each cuisine received? Then which customer which customer city spent most money? Spent the most money. Spent the most money. Now all these questions you can solve based on the questions I have solved just now. I have shown you as an example. Okay, I hope these questions will be easily solvable by you. Now another typical question I am giving. These 5 questions are of easy level. Another difficult question I am giving, this is the difficulty level a bit higher. How many customers ordered from each city? Okay, how many customers ordered from each city? Now I am giving you one hint. Let's see how many customers ordered from each city. In the customer table, we are having customer name and customer city, right? So in one column, in the one table only, we are having customer name and customer city. So most of you will be trying to do that. You will be grouping by in the same customer table, and you will not be doing the joining operation. Now if you look carefully, the question is having how many customers ordered. There is the word ordered. Who have ordered? The customers who have ordered. Only those customers city we want. Now Nisa have not ordered. Now after that you have to think. I have already solved 4 to 5 questions. Based on that questions only, this question can be solved. Okay, now let us move on to the query operation or query method, you can say. Query method. So this is a kind of filtering method. It is a filter method. Now without this method also you can filter. It's not like that you can't filter without this method, but we will be using the query method for something different thing, for some different kind of activities. Now for normal filtering we can use the normal filter method, but for some different thing we will be using this query method. I will say you why, but first let us understand that what is query method. Now suppose you are having a column as a name, age, salary, department. Okay, department. Now over here suppose I am taking as Rahul, Priya and Amit, 22, 25 and 28, 30,000, 50,000, 25,000, and their department is HR, IT and HR. Fine. Now I just want to find a question that is give all the records whose age is greater than 23. All records whose age is whose age is greater than 23, greater than 23. Now without query method, how you will be solving that? You will be using, suppose this data set is being stored in a variable known as df. This data frame we have made as a df. Now what we will be doing, we want all the records whose age is greater than 23. So you will be using df of df age is greater than 23. It will be returning you a data frame which will be having all the records which will be having the age more than 23. That is, it will be returning the age of Priya and Amit. It will be returning the records of Priya and Amit. Now with query method, how you will be solving that? Very easy thing. df.query. Now in place of these data frames, what you will be doing? df.query, and inside it you will be passing age greater than 23. That's it. Sorry, not here, here. Age greater than 23. That's it. Okay, I'm showing you another example. I just want salary greater than 40,000. Is there anyone? Yeah, salary greater than 40,000. I want all the records whose salary is greater than 40,000. Okay, so by normal method, what you will be doing? df of uh, the salary you will be writing, right, is greater than 40,000. This is how you will be writing. Now see, one thing I hope you guys have not thought for, that is, these entire records are in the form of data frame. Now if you see for each column, this name is the key, and these individual records are stored in the form of list. So ultimately this entire data frame is one dictionary. So df is one dictionary where we are having what? Key as name, and the records are being stored in the form of list, that is Rahul, then Priya. Like this it is getting stored. Okay, now that is why we are using for access. Suppose we want to get the salary, we want all the records whose salary is greater than 40,000. What you will be doing for accessing that salary column? What you will be doing? df of key. So you have written df of key is greater than 40,000. So df of salary is greater than 40,000. We want all the records for that. So when you will be using the query method, you can solve it very easily. df.query you will be writing df.query. Inside it you will be passing salary greater than 40,000. That's it. Done. Okay. Salary you have got. Now by this you can find many things, like all the things which you can do it with the filter method. You can, like normal filtering, you can do it with the help of query method as well. The things which you can do it with normal filtering, you can do it with the query methods as well. Fine. Now you will be learning another thing, that is indicators. Now you will be learning another thing, that is indicators. Wait, let me write it. Indicators. Now what are these things and how this will be used with query method? So indicators tells pandas, like we normally do, what we normally write, indicators is equals to true. Indicators, by default indicators are always false. So when you will be writing indicators is equals to true, it will be giving a uh, what can I say, it will be giving one instruction to panda, that after merging two tables, create one extra column that tells me where each row came from. Indicators is equals to true means after merging each column, after merging each column, merging each let's say after merging two tables, that will be better. After merging two tables, create one extra column, create one extra column that will tell us where each row came from, that will tell us where each row came from. Now I know by this definition things cannot be cleared. I will show you the practical example of it. I will show you the practical example of it. Let's move on to Colab directly, and we will work with that restaurant customer and orders example. Okay. Let's move on to Colab. So in Colab, you have already seen that we are having three tables. What are the three tables we are working with? Customers, restaurants, and the orders, right? And the order table is having customer ID and the restaurant ID, by which we can merge the restaurant and the customers. I hope these things are clear for you. Now let's move on to this part, that is indicators. Indicators. Now what these indicators will be doing? See, suppose I want to merge the restaurant table and the order table. I want to merge what? Restaurant table and the order table. So what I will be writing? pd.merge, and I want to merge what? Restaurants and the orders. Fine. On what I will be merging? On restaurant ID. On a restaurant ID I will be merging. Okay. And how I will be merging? I will be merging with left join. With left join. And now if I do indicator is equals to true. Sorry, indicators I will be in small letter. Remember this thing, indicators I will be in small letter, and by default indicator takes false. So we have to make it true. Indicator is equals to true. Now let's see that. If you run this, what you will be getting. So after that you are getting another extra column at the end of the table, that is underscore merge. So merge is what? See, we have done the left join, right? We have done the left join, and if we are merging restaurant and order, if we are merging restaurant and order, we will be getting all the restaurants who have got the orders. We will be getting all the restaurants who have got the orders. Now in the merge column we will be getting all the rows, that is both and left only. What's that mean by? So both means it is found in both the tables. Both means it is found in both the tables. That means restaurant ID, the I am merging both the table restaurant and order on basis of what column? Restaurant ID we are merging. So restaurant ID can be found on both the tables, restaurant and orders. For R01 it can be found in both order table and the restaurant table. For left only, what does it mean by? It meant by it is only found in the left table, but not in the right table. It is only found in the left table, but not in the right table. And if it is giving right only, that means it will be only found only in the right table, not in the left table. Now let's write this pd.merge. I am just using the right join instead of left join, orders and restaurants. Okay, on a restaurant ID. Very good. Then how I will be joining? With the help of a right join. And here indicator is equals to true. See, invalid syntax. What I have done? Oh, sorry. On is equals to. Yeah. See, it is giving right only, because it is taking every record from the left table, and only one restaurant is there who have not got any orders, who have not received any orders, and that is why that specific restaurant ID, that specific restaurant, that is green ball's restaurant ID, is not present in the order table, and that is why its record is present in the restaurant table but not present in the order table, and that is why it is giving right only. So it is found only in the right table, not in the left table. And when it is giving left only, the record is only found only in the left table, not in the right table. Got it? I hope the indicator concept is clear. Now, how you will be using indicators with query and why I have discussed that, why it is needed. Now, let us move on to a question by which you can understand this thing. Which customers have not placed any order? Have not placed any order. Which customers have not placed any order? Now, I want all the customers' name who have not placed the order. Now, by the normal way, I can get it that Nisa have not placed any order. But suppose uh, we are having a data set which is having more than 2 lakh data, because every day more than 2 crore 20 crore people are ordering on Zomato and Swiggy. How can Zomato and Swiggy figure it out that which customer is not giving the order, which customer is not giving the order? Yeah, can they found it? Obviously no, because they are having a huge number of data. But as because I have only 5 rows are present, so that's why we can easily figure it out that Nisa have not ordered. Verified. But if we want it in a full row format, if we want it in a panda format, in a data frame format, how can we find it that which customers have not placed any order? Okay. Let's solve this problem. For that, what we will be doing, first thing is clear that we have to merge restaurants with orders. We have to merge restaurants with orders, or customers, sorry, not restaurant, we have to merge customers with orders. So what we will be doing, pd dot merge, and you will be merging customers table, customers with orders. Very good. Now, on the basis of what you will be merging, you will be merging based on the customer ID. Customer ID, that is also clear. Now, how you will be merging? You will be merging on the basis of left join. Left join. Okay. Customers who have not placed the orders. Okay. Left join. And now, indicator you will be using is true. Now, here you will be using the query method. QUERY. Yeah. Query method, here you will be using, you want only that specific customer, which is having, which is not having, only that specific customer whose customer ID is not present in the order table, right? You want those customers whose customer ID is not present in the order table. I am writing this statement. I am breaking down this specific question. I want those customers whose customer ID is not present in the order table. This is what I want, right? Now, in the query, I will be giving underscore merge is equals to left only, as because it's a value, so it will be under a quote, left only. Done. And that's it. It will be giving you all the customers who have not placed any order. See, it is giving the detail of Nisa, as because Nisa is the only one over here who have not placed the order. So what I have done, see what I have done, I am repeating this indicator thing once again. Indicator is one thing which, like, by default indicator is always false. Okay, so indicator is one thing, indicator tells pandas after merging two tables, we have to create one extra column with the name of underscore merge, which will be telling us that from where each row is coming. From where each row is coming. See, it is giving both. That means the record is found in both the table. As because we are merging orders and restaurant, and we are checking the restaurant ID, whether the restaurant ID is present in both the orders and restaurant. That is what we want to find, right? Or where they are present. Inner join will be giving you only the common one, but left join will be giving you all the records from the left table, right? And a restaurant, like if you do indicator is equals to true, and if you are doing the left join or right join, it will be saying you that where they are present, where the restaurant ID is present and where they are not present. Now when you have done which customers have not placed any order, what you are doing? You are doing customers whose customer ID is not present in the order table. If a customer who is not giving any order, obviously his or her customer ID will not be present in the order table. Now we want only those customers, and that is why we are using query along with the indicators, because query function or query method will be helping us to use this merge column. And this merge column is coming why? Because of this indicator argument. Fine, I hope this thing is clear for you. If you have any doubt, please note down in the comment section. I will try to fix your doubt. Okay, I'm giving you another question as your homework based on this question only. Which restaurants have not received any order? Which restaurants have not received any order? This is the thing. Okay, so I hope the things are clear for you. 1 minute. Yeah, I hope the things are clear for you. So what are the things we have learned today? The things are, first of all, we have learned about joins, then joins with group by, joins with group by. We have learned a new method, that is sort values, right? We have learned about indicators, and we have learned about the query method. We have learned about the query method. Fine. So I hope things are clear for you. If you have any doubt, you can comment down in the comment section. And how do you like the video? You can comment down that as well. That's it for today. And in the next video, I will be uploading one project, end-to-end project of the EDA, where you will be doing the entire EDA, like the entire thing what you have learned from the very first video, that beginners video, to till what you have learned today. Everything will be covered in that project. Thank you everyone. Do subscribe and share this with your friends.